Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I hope you guys are all having a wonderful day. Kodo and anyone who might be lurking in chat, hey, thanks for being here. So today we're going to be continuing on with the convolution visualization and writing the convolution chapter and all that kind of stuff. As I mentioned yesterday, I only really have 2 more days left working with Klima. That is today and tomorrow. And then I'm kind of free to do my own thing for the next few weeks until my next job starts. So I'm going to try to do, somewhat longer streams. So I'm just trying to get my stream stamina up. So today I'm going to hopefully do a 4-hour stream from 4 to 8 p.m. Eastern. And then tomorrow, I don't know. I was thinking about maybe, not tomorrow, but Wednesday. I was thinking about maybe just trying to stream from 9 to 5, like a full weekday working hours worth of streaming. That's what I was thinking. But we'll see how it goes. Let me go ahead and get some water. And then I want to... All right, I'm going to ask you guys something really dumb, really quick before getting started. There's this problem I've been having with Twitch for the past, I don't know, like a few months or something like that. Let me just go to twitch.tv. It doesn't matter where, I'm pretty sure, twitch.tv. And let me just start using this site. I'm going to browse. I'll show you guys who I'm following. I don't know, I'll click on a random thing. Okay, it's not doing it now. I don't know why. For some reason, it's working just fine now. But my point is that I keep getting these weird, like module not defined or module not found errors. And sometimes I have to refresh the page like 5 or 6 times before I finally can, view a page on the site, which means every time that I have to, reload the page, I'm also rolling again for another potential ad that Twitch will show me because it's like, oh, you haven't been here before. So like sometimes before watching a stream, it'll take me a full minute just to get into the stream. That's not including the ad or anything else, just a full minute of just constantly refreshing the page to get the site to appear. So what I'm wondering is if anybody here has had a similar issue, to let me know the fix. It works fine on Chrome so far as I can see, but on Firefox it's an issue. And so I tried doing different browsers, but honestly I'm just kind of I've been using Firefox for too long. I'm willing to switch to the Qt browser, which I might do. Actually, maybe I try that. No, okay. Here's what we're going to do. Today, we're not going to use Firefox. We're going to use the Qt browser, and I'm just going to do that here, and we're just going to see how that goes. All right? Because I think I'm already logged in here. So if I do open github.com, I believe I'm already logged in. I'm not. Okay, give me a second, guys, to log in here. So, all right. Sign in. Sorry about this, guys. It should be... Yeah, okay, good. All right, 1 second. Yep. Oh, of course, because 2-factor authentication is the thing. Give me a second, guys. I promise I'll be back online. Just oh my gosh, why am I so bad? Like, just 2-factor authentication just bugs me. It shouldn't bug me, but it bugs me. Like, I know it's useful, but also, like, it makes it really, really difficult when you don't have a second factor, which I rarely have. Oh, gosh. 3... Okay. Yeah. Good. Okay. So now I'm logged in there. Let me go back over here. And let's now open up... how do you open up a new tab? Isn't it T? Or is it this? Well, let's do twitch.tv/simuleios. See what that does. Okay, seemed to work just fine. So now we have Simuleos up. Let's just see if this fixes our Twitch issues. Oh, shut up. I don't like you anyway. Okay, so we'll just see what happens. I'm going to try the Qt browser today. I'm going to monitor top, see how bad it is, and we'll go from there. Kodo, don't push yourself too hard. I've gotten that before. I think Twitch has been having some issues as of late. Hey, Amaris, how are you? Works fine on the app so far. Yeah, anyway. I'm just going to try to switch out of Firefox. I've been wanting to switch from Firefox for a while now. I mean, don't get me wrong, Firefox is great. But every now and again, there's like some sort of issue that appears with Firefox that I just kind of, need to get around. And honestly, the only reason I was using Firefox, to be totally and completely honest, was because of the ad blocking. And yeah, fine. Like, I'll just watch some ads. It's fine. Besides, it doesn't even block the ads on Twitch anymore. Like, it was really just for ad blocking on Twitch. That was the only reason I was using Firefox. outside of that, there's no legitimate reason. I don't really like the workflow or its appearance or anything like that too much. Don't get me wrong though, I do want to support Mozilla because Mozilla is a big open source development company, and I feel like you want to support people like that. So I don't know. Anyway, yeah, I guess we can go ahead and just hop into it, see how you guys are doing. Yeah, everything seems fine on my end. Can I do this? Yeah, that'll work. Perfect. Okay. So what are we working on today? Let me just go here and do Convolutions, Wikipedia. Let's see what we got. Just saw this. Let's see what that is. Open, paste. What do you have? Oh yeah, I saw that as well. I thought it was pretty funny. How do you view an image? Can I just view an image? Don't. Let me see what happens if I try that. So if I do this and I do save image. Interesting. Change your ad blocker plugin. Yeah, so I mean, I've been using the same ad blocker plugin for a long time. But I just haven't, I don't know. It's fine. Like, I feel like I shouldn't be blocking ads anyway. Like, honestly, on YouTube, I don't block ads on YouTube because I like to support the content creators anyway. But on Twitch, the ads are just so intrusive that I feel like I have to block them. It's really difficult to watch Twitch with the ads. So, besides which, a lot of times, like, I'm not even like, I don't even want to watch the stream. Like, a lot of times when I'm on Twitch, like, I'm looking for a stream to watch. So I'm just like kind of going from stream to stream to stream. And so like, a lot of times that's what I'm doing. I'm just kind of browsing to see what's on. And because of that, the ads are super intrusive. And also, like, when I'm trying to find someone to raid, like, sometimes I'll just like browse like different channels, right? And I just need to see what they're doing, see if they're going to leave before the raid. But if an ad appears, then it's like, well, how am I supposed to do that? Anyway, let's just going. Hey, TS Jobs, how are you? Okay, so let's just see what happens. So, it seems to have 2 unskippable ads several times in a row on the YouTube app is really annoying. That's true as well. I don't know. Like, yeah, we can go back to Firefox. It was fine. Firefox was fine just a second ago. So maybe it's totally fine. I have no idea. We'll see. Like, what's the worst that could happen? How do I make the text bigger? Probably Control plus. Control plus. Let's try this. Qt browser. Zoom. See what we got here. Oh, I remember. The reason I didn't use this last time was that it was super slow for some reason. Okay. How do we make the zoom? I should not be trying. How do you go back? Oh no. You? Oh, let's try this again. Qt browser. Keybinds. See what we got here. Sure. Install changelog contribution, donate. I'm looking for the keybinds. Donating, sponsors, authors, similar projects, inactive. No, that doesn't help me at all. Your browser is so ugly? Oh, I actually really like my browser. That's like one of the selling points of Qt browser. It looks really nice. But that's fine, I guess. If you don't like it, that's okay. But yeah, honestly, like compared to Firefox, like here's Firefox. Like, this is ugly. Like, undoubtedly, this is ugly. There's a little top bar here. And especially compared to like Chrome, for example, Chrome is super ugly. Right? Like all this stuff is just gross looking. But like Qt browser is like, I like it. It looks nice. Like the only thing that I don't like about it is the ad blocking. Documentation. Is there a documentation? I don't see any documentation. Ah, here it is. Documentation keybind cheat sheet. Yep. Okay. So what I'm looking for. Okay, I'm probably gonna need to use this a bunch. So. Quick load bookmark. How do I save a bookmark? Save bookmark is going to be M. So this is going to be cute cheat sheet. I guess. How do you spell sheet? I guess that's fine. Okay. So what am I going to do then? To search, I know how to search. What was I looking for? Oh, I don't remember what I was looking for. So let's just move this back here. We'll use it later in stream. And yeah, we can just go from there. Let's see. Hey Radu, how are you? Okay, so I think we're good to go. If there's something I have questions on, I'll just figure it out. Oh yeah, I need to figure out how to zoom. Oh no. Zoom in, it's just plus, that's it? So if I go here and I just do plus. Ah, sugoi na. And then minus must be... Ah, nice. Okay, now I don't know why there's a little red thing at the bottom of my screen. Okay, fine, fair enough. Cool, okay, I'm happy with that. I believe H, J, K, and L will zoom. All right, okay. I'm okay with that, that's pretty nice. All right, right, so what are we doing today? So today we're gonna be continuing what we were talking about yesterday. Let me just explain how the whole project works, what we're kind of doing, the ideas, all this kind of stuff, and then we're going to hop into the convolution visualization. Well, actually, we don't have too many people here, so I assume most of the people that are on stream probably are coming to stream because they saw stream yesterday. It just said stream like 10 times in that past, 10 minutes or something. Any plans to stream early in the day? Yeah, so I just mentioned this before, but, first of all, 4 o'clock p.m. is kind of early compared to what I was streaming earlier. But also, yeah, I do intend to try to stream, more regular working hours in a way, starting on Wednesday, just for a week or two, just to see what we can do. And then we can go from there. So, in principle, I should be streaming a bit earlier, starting on Wednesday, and I'm not going to make any promises as to what the stream times will be. But I'm going to do what I can to do some earlier streaming if possible. And again, that would start on Wednesday because tomorrow is the last day I'm working for Klima. And we'll see how it is. But yeah, again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. Jaka Brent Haskell, you're 1,000 times smarter than me. That's almost certainly not true, but hey, I guess I'll take the compliment. Thank you for that. Okay, again, we'll kind of introduce the project and everything, maybe 30 minutes or so when we have a few more people online. Although, that being said, I don't really know how many people will show up for a weekday Monday stream when everyone gets back to work today, all this kind of stuff. So it might just be kind of a chill, relaxed day. So again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. So I'm going to open up a new terminal, and I'm just going to cd into projects. Simuleos and convolutions, L is here, and I'm just going to play mpv out 6.mp4 loop 0. And so this is the visualization we made the other day. Okay, so I'll just make it bigger, something like that. There we go. Okay, so this is the visualization for convolutions that we were looking at. Do you know anything about quantum computers? We actually did a full month where we just looked at quantum computing and stuff like that. So the answer is yes. I know a good bit about quantum computing, but not as much as, for example, my girlfriend or a lot of other people who've studied it during their PhD studies. Mine was more of a fascination with it. And again, my PhD is in quantum simulation, not quantum computation. And those two things are kind of different. That is to say, I simulate quantum matter. I do not do things with qubits. But I know a bit, enough to be able to implement Shor's algorithm and stuff like that. But that's about as much as I could really talk about. Okay, so what is it that we're looking at here? Right now we're looking at a one-dimensional visualization for convolutions, right? So the idea here is this little red-orange curve that's moving along. That is going to be our filter, which is denoted here as G. And our signal is this blue curve that's denoted as F. Essentially, at every point in the simulation, we're trying to figure out what the output convolution will be, and the output convolution is this pink line over here. So at any point, let's say I pause here, we're looking to figure out what the next element of the convolution will be, and it's literally just signal 1 times signal 2. And that's all it is. And what we do is we have signal 2 move across the screen, and then sum the area under signal 1 and signal 2 to get the next value for the convolution. Now, a lot of people might be asking, what are convolutions useful for? That's a very good question. Convolutions are mainly used in image processing. Well, they're used all over the place for multiplication and a bunch of other things. But for the most part, when you think about convolutions, most people think of them in terms of image processing, where we typically consider... how do I put this? We typically consider Gaussian blurs or Sobel operators or things that act on filters on top of images. And that's kind of where this idea of convolving with a filter or applying a filter is done through a convolution, right? So that's kind of why we think about convolutions a lot. I have my first quantum cryptography lecture tomorrow. Oh, actually really cool. What is your... Okay, if this is too personal, you don't have to answer. But my question is, what are you studying such that quantum cryptography appears in the curriculum, right? Because that was not something that was even offered at my undergraduate, and I was also not offered it as a PhD student, although I did learn it a little bit on my own. Actually, not very much at all on my own, if I'm being honest. You study specifically cryptography. Okay, that's fair. Your girlfriend will hack all your encrypted secret stuff. I think the idea that, you know, when quantum computers come online, that they're just going to completely wreck the like encrypted space, like all encrypted methods and stuff like that. I mean, there's some evidence to believe that, but also like one-time pad encoding is kind of, I think, a bit more difficult to break than people give it credit for. But also, maybe I'm just talking about stuff that I know nothing about. I will say though, if like I don't really have any encrypted stuff that I don't want my girlfriend to see, like, or I don't care if she sees, you know, like, who cares? Like, what's the worst that happens? She gets into my bank account? Oh no. Like, that's like, who cares? Like, now, admittedly, if it wasn't my girlfriend and it was a nefarious person, you know, who really wanted to steal all my money, okay, fine, fair enough. 100% with you, but it's my girlfriend, so I don't mind, you know? Like, all right. No, I know you're joking. I was just joking along with you. All right, let's move this. Oh, nope. 1 second. Let's try to do this again. Okay, let's move this up here. Okay, I guess one last thing before I start. I do want to plug a few things on Wednesday from 6 to 8 p.m. Eastern. That should be after most of the day of streaming. I will be doing another Writing Wednesday. I do want to have that be a regular thing where we just do something other than programming or technical work for once and do some, you know, short story writing and reading. Also, if you guys are interested in non-programming streams, do definitely let me know. Because I am very interested to hear what you guys actually want to watch besides programming. Te amo mucho. Thank you so much for following. Really appreciate it. Right. So I guess this is a good point after we've described kind of what convolutions are to talk about how this, you know, kind of works all together into our Becoming a Fractal project and why the title of the stream is Becoming a Fractal. So this all starts with a discussion we had a long time ago for iterated function systems, which are ways in which you can create fractal-like images and stuff like that. So if I cd into projects, flamify, oops, sorry. And then I ls here and I run mirage check.png, we can actually create a bunch of these images that look something like this, which is a combination of a bunch of different iterated function systems, a bunch of different fractal patterns put together. So this is kind of like a sinusoidal fractal mixed with a heart fractal, blah, blah, blah. And this is like a heart mixed with, I don't know, like a bunch of other fractals and stuff like that. The point is, in order to create these images, at some point we have to do a convolution. That is to say, at areas where we have very low density of points, we actually will blur those points, those areas. And then over here, we don't do the blurring as much. So the idea is if we have a low density of points, we're going to want to apply a Gaussian kernel via a convolution. So that's where convolutions come into play. Now, what we're going to do with this ability to basically plot like a number of fractals put together is we're actually going to try to read in an image, right? And this image will be like my face or something like that. It doesn't really matter what. And the idea is that I want to return back a set of fractal flames that will adequately represent that image. So I want to be able to turn any image into a fractal. And the way we're going to do this is by first doing the fractal flame method, optimizing it and doing that in parallel with kernel abstractions in Julia. So we can do both GPU and CPU optimization. And then also on top of that, adding in a genetic algorithm. Now we have a lot to do. We've only really got the fractal flame method in, but that's kind of why we're kind of starting at the back, and we're going to be implementing the chapters for convolutions and stuff like that into the algorithm archive in the next few weeks, so that when we have everything kind of put together, once we have everything put together, we should be able to have a clear and consistent guide for everyone to read through and understand how we got from point A to point B without having to go through all of that detail in the video itself. And that's kind of the idea. I want to have like as much of this described in the algorithm archive as possible. So that's why we're starting at the very basics with convolutions first. Let's see. I also study quantum resistant crypto systems. That's actually really cool. Literally, I love you very much. Te amo. I thought it was te amor. What's the difference between amo and amor in Spanish? Nice eye, by the way. Thanks. You too. It's a flame. I think I want to see the Simul Wow image flamified. We could do that one. That would be an interesting one to flamify. But we'll see. We'll see how it goes. I'm not sure. So the issue with this is going to be that the genetic algorithm that we use is going to like, how do I put this? The genetic algorithm that we're going to have to use is going to have to traverse through an n-dimensional space where n is large, like probably in the hundreds. So it's going to be kind of difficult to go from where we are now to where we need to be. Is it important to learn MATLAB or Python and C++ are good enough? Oh, I see. Thanks for that, Amaris. I guess I just don't know enough Spanish. Is it important to learn MATLAB or Python and C++ are good enough? Wait, I'm not sure if you're... I'm not sure what you're asking here, but if you're asking, is one language good enough for me to do a particular project? The answer is probably, but it depends on the language and depends on what you want to do and all this kind of stuff. So I would argue that if you're trying to learn a language, try to just kind of look around for other projects that do something similar to what you want to do and learn the language that they're using for that project is kind of what I would suggest. So if everyone else is using Python for their project, use Python. If everyone else is using C#, use C#. This type of thing. I wouldn't rock the boat if you're just trying to figure out what languages to know. Now, if you already know a couple languages and you're trying to see, should I learn more, that really, again, depends on like what jobs you're applying to, you know, all this kind of stuff. So in other words, do you need MATLAB or can you get by with only Python and C++? Yeah, okay. In that case, yeah. Probably you don't need MATLAB. I've never really seen a situation where you actually need to use MATLAB. If everyone's using JavaScript, you just run and never look back. Thanks, mate. That's what I was looking for. Yeah, I hope that was helpful. Okay, let's go ahead and remove the giant eye of Sauron. Well, I guess blue eye of Sauron. I'm not really sure. CD projects, Simuleos, and then Convolutions. And over here, CD projects, Simuleos, and Convolutions. Alice here. And let's go ahead and clear here. We get a quick sip of water, and we'll talk about what we did yesterday. And what we need to do today, and, you know, all that kind of stuff, where we're going. Okay, so let's go ahead and open up some images. So I'm going to do Mirage, just out 0001.png. Right. So as of yesterday, we basically made this visualization. We have a square wave and we have a triangle coming into the square wave. And essentially the idea is we do some sort of convolution with it. Now, what Amaras and a few other people did astutely notice is that the visualization is kind of wrong. That is to say, the triangle should be going the other direction at the very least, but there might be a few other issues with it. So I'm going to try to create like a more consistent, right? So in the end, I'm trying to replicate a particular visualization on Wikipedia, and that would be, well, maybe not. Let's just go back up here. I think what I'm going to try to do is replicate this visualization here. And then we can make sure, yeah, so I'm going to try to replicate this visualization here, which is not what I'm currently doing. So I need to figure out why we're getting the same answer for our convolution, even though it looks like we're doing something slightly different. So anyway, there's a lot of things that I need to figure out. So we're going to try to do it. If you're trying to load 4D MRI data, I would recommend MATLAB. I would still not recommend MATLAB because it's an awful excuse for a programming language, but hey, you know, whatever. All depends on your requirements, of course. Yeah, right. I mean, MATLAB is a language I would never encourage anyone to learn unless they absolutely have to. And even then, I would probably encourage them to support other open source projects like Julia or something else, because it's just an awful language. But again, we're not going to rant about that. I've done way too many rants on this stream about how much I hate MATLAB and why it's absolute garbage and all this kind of stuff. But anyway, let's not talk about that. Okay, so let's go ahead and get the F and G correct, and then we'll make sure we're getting the right convolution out. So I'm going to basically mimic this F and G that we have in here. And then what am I going to do? I think after that, we're just going to make sure that we have the right convolved output, and then we get the visualization to match as well. So that's kind of what we're going to start with today, and then we go from there. Again, I'm pretty sure today's going to be more relaxed. Like I'm almost positive we're going to have way fewer people watching today than we did yesterday or the day before that. Just because, again, it's like the first Monday of 2021 where everyone needs to go back to work and all that kind of stuff. So I'm not really expecting to have too many people here. So if you guys have any specific questions, comments, concerns, anything like that, just let me know and I'll totally address it as soon as I see it in chat. But yeah, I'm hoping that we get some work done today is kind of the goal. 1 second. Sorry, I accidentally closed a tab on my side screen that I didn't mean to do. And the issue is that I have a really... Alright, well, let's try that again. Okay, well, never mind. I can't fix that. Well, maybe I can. Yeah, okay. 1 second, sorry. Try that again. Okay, there we go. Okay, so good. Okay, seems good to go. Sorry about that. That was kind of weird that I just started saying okay and you guys didn't see any of what I was doing. But that is what it is. Where are all the people that are looking at this pull requests? We don't have them. That's the issue. And I've mentioned this anytime anyone wants to like submit anything to the algorithm archive. We are currently really missing people who choose to do reviews. So if you want to help with the algorithm archive, the #1 way to help is just to go to the set of PRs that we have and just look at any of them. And if there's any languages that you see that you know that are awaiting review, just look at that language and be like, yo dog, this, like, you don't check the algorithm, just check the language. Make sure that the language is readable. That's all I need to know. And if the language is readable, then I can check the algorithm and we're good to go. Like C252 there. Yeah, so there were a few, but honestly, like, we can't just keep expecting them to keep helping out, you know? Like, we really gotta, like, you know, get new people into the fold. Mr. Ed Makes, thank you so much for following. Really appreciate it. Really appreciate it. There we go. I can't speak. Just forgive me. Okay, so let's go to VI Convolution .jl, move down here. Some are reviewed, I think. Maybe they are. We can take a look at that later. I mean, I'm kind of stretched for time as well. I mean, again, starting Wednesday, I'll have way more time, and we should be able to spend some time doing specifically algorithm archive work, algorithm archive reviews, this type of stuff. But right now, I don't quite have the time. Okay, so what I'm going to try to do now is make this visualization here. So I'm just going to do a giant triangle and a square. Yep, that's what I want to do. So let's just do it. So we already have the square wave, and we are going to normalize x. So now the next thing I want to do is have y be a set of, looks like 40 elements. So y is going to be equal to the $, and I'm just going to say I for I equals 1, 40 minus 1, 1. Sure, that should do it. And so this should iterate back through, and then we should normalize that. Okay, so let's see what happens when we run that. So Julia, let's run the last include, and then we're just going to try to run main and see where this goes. Yeah, no, we're desperately lacking people to do reviews with the algorithm archive right now. I'm 100%, like, I totally understand that issue. But I don't really have a good solution for it. Let's do I plus something like that. Now let's try it again, main. Oh, what's going on? What do we have? What's this witchery you're creating? We're just doing a basic convolution visualization. So convolutions are useful for applying filters to images and stuff like that. Okay, so what's the issue here? This is going to be an issue with line 67. Okay, it doesn't like normalize on Y, really? Let's just print line Y. Y. And see what we got. So now we're going to do include main. Okay, what's the issue here? It is 40, 39, 38. Yeah, this should be fine. Like, this is what I expected, but maybe it is a complex N64. Let me output the type of Y. Oop. Sorry about that. Okay, let's try that. Include main. Okay, the type of Y is array complex N64. Why is this not working? Let's just try this over here in the REPL and see what we get. So we're going to grab this guy. Okay, and now let's just do normalize Y. What does that do? That works. Normalize exclamation mark Y. That one does not work. I see. That's because it assumes that I is a double or an integer. So if we do float float of 1 does what? Okay, so let's just do float of I. Try that. Now we're going to try include. And now let's try main again. This should run, I think, and then we'll get a bunch of pictures and we can kind of look at them and see what's happening. So let me get some water. But again, guys, if there's like any type of, like if you guys would be interested in watching gaming content, for example, or anything like that, just let me know. I don't normally do that, but I'm trying to think of and see if there are other things that you guys might enjoy. Maybe it's just I do other things besides programming and see if you guys like it or not, and then we go from there. That could be what we do, like maybe challenge runs in Guild Wars or something. I don't know. So let's do Mirage out. Okay, so here we have the triangle. It's bigger than the square. It goes up. Oh, hello. Okay. That wasn't exactly what I thought would happen. This is because 40 to 60 is only 20 elements. So let's try this again. It's still buggy. Yeah, it's definitely still buggy. Wait, what's still buggy? Actually, sorry. I include main. Okay, so we should get a few, issues there. So now we're going to do Mirage. Okay, so here's our triangle. It should go up. And then it goes back down. Okay, so first of all, is that the expected output of a convolution? It is, no, it's the opposite output. So we're actually outputting the correlation, not the convolution, which is good to know. So we need to fix that. Yeah. So another thing that we should probably do here is make this go from 19 to 0 instead. Actually, let me check that really quick. Well, let's just do y. That's 40 elements. Yeah, so we want to do 19 to 0 instead. And then we normalize it. That should be fine. Okay, so that is correct. We're getting the wrong output for our convolution. Let me just run this one more time. Include main, and then we'll talk about what we need to do. One thing we definitely need to do is flip the signal, but we also need to move it the other way across the image. Okay, so we're going to do... Actually, I think the direction in which... Wait, do we flip the signal or do we just move the direction? Let's see what we're getting. Mirage out.png. Move this in. Okay, so we got that. Let's move this over. And let's go from there. Okay, so this is going... So it should be... See how it kind of goes up exponentially and then drops down in this way? It should go up in this kind of... not exponential. I don't know how to say it, but like clearly we have the wrong shape. Wouldn't it be better to use some constants and just use that everywhere rather than change 40 here, 20 here? I don't know what you mean. I'm sorry about that. Could you explain? Yeah, I have no idea what you're talking about. I'm so sorry. Okay. So, right. So the big thing is that we need to flip the signal. Okay. But let me see. What's going on over here? So we have... In fact, I think... Wait, let me just take a look at this a bit more. Let's go here. In code, you have a lot of numbers that you have to change when you modify one of them. You have a lot of 20s, 1 to 40 and 60. Right, so the reason I have that is because we're changing the shape of the... we're changing the signals that we're inputting. So I don't really have... Like, that's only in the setting of the signals, so I don't think we can get around that. I mean, I suppose we could get around that by, no, I don't think we can get around that. I mean, maybe we can. I just don't know how. Okay. So first of all, I think that this is wrong. Yeah, I'm pretty sure this is wrong. Okay. Because what we should be seeing is a very strong acceleration at the start, and we see a weak acceleration, and then very strong decay, but again, we see a weak decay. So this visualization is wrong in a lot of different ways. That the convolution curve does not match the convolution visualization that we have. But the convolution visualization that we have should be correct. No, I just don't understand. No, so this is still the correlation. It's just the correlation. So we're doing this guy down here. That's what we're doing. That's the visualization we're doing. The convolution is flipped, actually. Yeah, so that's the other thing that we clearly did wrong. So let's go here, and let's fix that convolution. So here's our linear convolution here. Yeah, so this is actually quite complicated to make yesterday, so I don't know how far we're going to get today. Like, we're just going to have to see where it goes. So, it's going to be I plus length of signal 2, and here we're saying the sum. I mean, it would be easier to change them from one place rather than check them out in a lot of places. It seems like everything is related to the value of 20 anyway. No, okay, so just for the record, Radu, I'm still not fully understanding what you're saying. I'm only changing it here in these 3 lines, or maybe 4 lines. So I'm not, like, that's the only place I'm really doing the change. So I'm sorry, I'm not like trying to pick a fight here. I still don't understand the point. So sorry about that. Okay. So here we have our sum is going to be equal to the sum of, yeah. So the issue here is that signal 2 needs to be flipped. Can we just invert a signal? Like, how do we invert? Norm factor is 20. Y is 40 plus 20. Y is, norm factor is 20. Y is 40 plus 20. Y is 40 plus 20. Y is, I don't know what you're getting. I'm so sorry. Which is 20. The norm factor being 20 is unrelated. Also, I don't know. So that's all commented out. So none of this is being used. In fact, I could probably just remove all of this right now. Let's just remove all that because that's all commented out. So yeah, I mean, it'd just be a bit more work, but yeah, we could do that if we wanted to. Anyway, okay, so up here we're gonna do the residual sum. So what I want to do is I want to invert a signal so that yeah, maybe there is a way to do that. So let me do A is going to be equal to, let's do I for I equals 1 to 10 or something like that. And then we're just gonna do A from end minus 1, 1 and see what happens. Okay, that does do it backwards. So here we could just do signal 2 from end minus 1, 1. And that'll work for that one. Now this one's going to be slightly more complicated. No, it's not. It's going to be the same thing. 1. Here, right that. Yeah, okay, so let's see what happens if we run that. Now we're going to do include. What? Oh, I see. My bad. Main. All right, give that a second to run. And then we should at least get the right convolution this time. It's a bird is plane. It's the Seljuk Turks reverse signal. Oh, and let's see what happens. So reverse A. Well, maybe we do that one because it's slightly easier. I guess. What? I saw Gothic Death Eater's name, and so I read it in Japanese because on my screen it's in English. All right, so here we're gonna do reverse, and let's see what happens. Was that a YouTube link? So let's do include main one more time, and let's just take a look at this. Okay, so now we're gonna do. 1 second, I've got to think about this. We're gonna run mirage out.png. Okay, so here we're gonna at least get the right convolution visualization. So the convolution is right, but the visualization is wrong now. So what we need to do now is we need to flip the signal and then make it go the other direction. So that's what we need. Could you post the whole link? You don't have to post just the end of it. You can post the whole thing, I think. That's fine. 1 second. Wait, does everyone have a colon after their name? Oh, interesting. Weird. Okay, so in my secondary chat I have over here, Gothic Death Eater's name is so big that it covers the entire screen, and then the colon is for some reason on the next line. Let's see what we got here. Oh, try that one again. Okay, try that one again. Oh, I remember why I didn't like the Qt browser now. I totally remember. When I yank... Oh, yeah, okay. This is going to be a pain. Yeah, I remember why I don't like it now.
It's a bird, it's a plane.
Oh, fair enough. So I can't actually copy this URL in any way. If I yank it, then I have to... Yeah, I can't copy it. Yeah, because it copies to the wrong clipboard. Let me try to Google that really quick. Qt browser. Qt browser copying to mouse clipboard. Let's see what we got here. Copy entire image. Do you use the mouse at all? If so, when? Difficulty copying to clipboard. Let's see, Midnight Commander. The issue is copy to clipboard doesn't work as per suggestion given. Well, let's just see. Maybe there's a different clipboard I can copy to. Sorry, I'm now going to talk a little. Sorry, I'm kind of moving back and forth. So yank. We have two different yanks. What happens if we just do this yank? Yank. That does that one. So what about capital Y? No, that doesn't do anything. But can I just do, no, I can't grab the URL there. So there were some Turks that made an empire, but not the Ottoman Empire. Yeah, I guess so. I'm sorry, I should know history, but I don't know history because I'm bad. By the way, Ozgesian1, thank you so much for following, really appreciate it. Okay, so my question with the Qt browser is so whenever I copy and paste, I never use Control-C and Control-V. I always copy with my mouse, and I just paste with the middle click. That's what I do. So how do I get a Qt browser? Let's just do google.com. And then we're just going to say Qt browser, copy to mouse, buffer. Let's see. It's a way to select text using the keyboard in Qt browser. So hit enter, visual mode. Text is selected Y, copy it to clipboard, visual mode. That's not what I need because it yanks to the wrong clipboard. Yank seems to have some extra info in the cheat sheet. YouTube seems to be the copy of the clipboard. Okay, let me see. Yank. Answers, enter. Wait, what? Yank. Huh. See, this is what I get for trying to learn a new browser, right? The thing is, I like this browser. I like the idea of this browser. It's super nice. It's clean. It's crisp. One in the bottom. Copying yank URL. Copy URL to selection. Copy title to clipboard. Copy title to selection. No, I do want to copy URL to selection. It's copy title to clipboard. Okay, let's see what happens if I just do YT. Okay. And then if I try to paste that. No, that doesn't work. Let's try Y capital Y. So Y capital Y. And let's see if we paste that. That seemed to maybe have worked. Wait, let's see. Let's try that again. Okay, so I'm just going to grab this. All right, so I'm now copying that. That pastes exactly what I expected. So now I'm going to go over here, and we're going to do YT. And now we're going to paste here. That did not work. Over here, now we're going to do Y capital Y. Paste over here. That did work. Nice. Okay, here's the cheat sheet. All right, that's all I needed. So now I'm very happy to use this browser. What on earth are we doing? What on earth are we doing? That is a very good question. Thank you so much for asking. I really never know myself, but sometimes I pretend to know. So let me go to algorithmarchive.org. Okay. Interesting. We are working on a online educational resource known as the Arcane Algorithm Archive. The idea here is if you go to Gaussian elimination, for example, we basically have the process of Gaussian elimination and also a bunch of different languages for you to choose from. And so the idea is we're working on a new chapter for convolutions, which are typically used in image processing. And the hope is that we're going to talk about convolutions and move into the fractal flame method, which we've already done, and eventually run to a stage where we're able to put any image into our fractal flame method and then output a set of fractals that look very similar to the image that we're reading in, thereby turning any image into a fractal and hence becoming a fractal. That's kind of the idea. That's where we're going to go. We're going to see how far we get. I really don't know, but we'll see. Okay. So right now we're still doing the convolution visualizations, which I think we're so close to being done. Okay, my brain is smoking now. Yeah, sorry, that was super quick. Maybe I should have talked about it in a bit more detail, but it is what it is. Okay. So now for the signal plot. What we're going to want to do here is we're going to want to flip the filter. So shift signal is going to be equal to this. And what I actually want to do is I want to make it so the zeros appear here. So let's do zeros of n1 minus n2 there. And then if we just do DTS here. Oh. I see. Try that again. And now we're going to move down here. Antoine309, thank you so much for following. Really appreciate it. And here we're just going to do signal, because that's actually faster. And then DT there. Perfect. Signal 1, I believe. No, signal... No, signal 1 is correct. Okay. So now we have the shifted signal. Right. So I think what I actually want to do is reverse signal 2 here. Okay. And then what we want to do is we want to make it so the shifted signal is going to be equal to signal 2 from I to N1 minus 1 and signal 2 from 1 to I. So what we actually want to do is make it so... Let me just write this. So the idea here is that we have this shifted signal that we're moving along. So we've read in I, which is the iteration that we're on. It's essentially what element. So we're looking at this visualization over here. It's essentially which element of this little purple line we're drawing at that particular point in time. And so what we were doing before is we were making it so at every iteration I, what we're going to do is we're going to take the signal that we're shifting, and we're going to take the end of the signal, and we're going to move that to the beginning, and then we're going to take the start of the signal and move that to the end, which seems fine. So if I is equal to 1, let's just say, or I is equal to 10, doesn't matter. We're going to grab from 10 to 90, and we're going to move that in front of the signal. Wait a minute, I think I'm doing this wrong. I'm just gonna run this, see what happens. I'm sorry, I'm a bit confused. Let's just do include main, and then we'll just see what happens, and then we'll try to figure that out. Great, okay, so now we're gonna do Mirage. Okay, so the signal is correct. It's just going the wrong direction now. Wonderful. Okay, so now we just have to make sure it goes the right direction. So now it just has to go... Now it just has to go towards the right. That's what we need to do next. So how are we going to do that then? Okay. So what visualization are we looking at here? Let's just kind of walk through this. So right now what we're doing, how much time do you need to understand something like this? It takes time, but the truth is, so the purpose of this stream is to kind of learn together with the audience, me, you, and the rest of the world all tackling complex math together. In some sense, that's kind of what we're doing. And so as long as you stick around and you ask questions whenever a question pops into your head, I think eventually people start to pick up and start to understand. It's not so much about like studying on one particular topic. It's about just being around and asking and trying to understand. And the more you try to understand, kind of the further you get, RJ Helms, thank you so much for following. Really appreciate it. So again, if you have a specific question, feel free to ask. Right now, again, what we're focusing on is a convolution, which is typically used in image processing to apply like a filter. You can think like Snapchat filters or something like that, except probably just Gaussian blur, and we go from there. It's elementary math, but really hard to get your head around convolutions. Oh yeah, super hard. Like this is, I mean, I've got a PhD in computational something something, and like I still have, I'm struggling with this quite. I mean, you can see I'm struggling pretty hard, especially when you're talking about the theory of distributions, which I don't think we're even getting to, honestly. I think we're literally just doing the basic convolutions. A college, a master's, a doctorate, and a postdoctorate sounds legit. I don't have a master's, but I do have an undergraduate, a doctorate, and a postdoctorate. No master's, so I'm not quite that pro. What is a convolution? That's a good question. So let me go back to this visualization that you see up here. And let me just make this bigger, and let's let it run. So basically what we're doing at every time step is we're multiplying the red and blue lines together, right? And then we get this kind of green curve that we are summing underneath. So we're multiplying the red and green together to get this green thing. I'm sorry, scratch that. We're multiplying the red and blue together to get this green curve that we integrate. After integrating that, we then find the value of this purple curve, which is a convolution at every step. So as this little green curve gets smaller and smaller, the convolution gets smaller and smaller until this point when there is no value to the convolution. And then as these guys start to overlap again, and there is some like multiplied output, eventually the convolution goes up again. So this is kind of what the convolution does. Now, the question of what does a convolution do, what is a convolution, is usually overshadowed by the question of why do you want to use a convolution? And for the most part, convolutions are they're actually used in quite a lot of places. Like if you want to perform a derivative operation, a lot of times these derivatives are applications of a Sobel operation, which is a way in which you can apply a particular filter to a signal. So kind of the idea here is if you take an image and you want to just blur the image, well, you'll apply a Gaussian like this to the image. If you want to find the image derivatives, you might apply a filter that kind of goes down and up again or something like that. If you want to find a whole bunch of other things, like basically you're just applying, like for example, we did an application of convolutions the other day where multiplication of integers was just a convolution, you know, this type of stuff, you know? So, okay, let's go here, up here, let's go over here. Even though I don't understand immediately, being familiar with some topics is useful. If I need them in the future, I would have some idea of what I should look for. That's still a benefit, I think. Right. Well, you can only introduce distributions through generalizing convolutions, I think. Maybe. I thought everyone is on that baloney system since a long time ago. Wait, what is a baloney system? Adoos Madoos, thank you so much for following. Really appreciate it. Okay. So now we just have to make sure that this visualization moves in the right direction. Only Europeans follow the... What is this system? Should I know this system? Maybe I should. So this is a series of ministerial meetings and agreements between European countries to ensure comparability and standards of quality of higher educational qualifications. Ah, I see. So how do you pronounce Bologna? Am I pronouncing it incorrectly? I thought that's how you pronounce baloney, but I feel like I must be... pronouns. Okay, what do we have here? How to pronounce it in English? Bologna. A Bologna. I see, interesting. It's bologna for North American lunch meat. See, that's what I thought. I'm sorry, I'm so uncultured. I didn't even know. I'm sorry. Basically, bachelor's in 3 years, master's in 2, doctorate in 3. Right. So yeah, so the U.S. does a slightly different system. You do undergraduate in 4 to 5 years and PhD in 5 to 7 years is kind of what they do. It's actually remarkably different. Like you can get your doctorate way faster in Europe than you can in the U.S. Bologna, I think. Yeah, I think that's how it should be pronounced, I guess. But my bad, I'm just an uncultured swine. Hence why I was calling it baloney. Anyway, what do we have here? So signal 2. So what's the idea here? So every image here is another iteration. So here's I is equal to 1, 2, 3, 4, 5, 6, 7. What I want to do is make it so this image goes the other direction. So what I'm going to do is I'm going to take the end of the signal. I'm going to take the end of the signal, which is going to be signal 2. It's going to be I see. Okay. So we want the end of the signal, and we want to put that first. I gotta think about this. So I think we want N. So N1 and N2 should be, so we want N1 minus I. Okay. To N1 minus 1. And then here we're going to do 1 to N1 minus I. Let's see if that does it. Just making stuff up at this point. So let's do include, main, see what happens. What's the worst that could happen, right? Raj, yeah, look at that. And it looks like we're doing the right visualization. Everything is hunky-dory. Wonderful. Okay. Now, admittedly, right, this particular visualization is kind of garbage because, well, various reasons, which we'll fix in a second. But for the most part, this is doing the right visualization. So what I'm going to do now is I'm going to go ahead and write quit, git add convolution.jl, git commit, -m, adding appropriate visualization, and fixing convolution. All right, git push, origin, master, I believe. By the way, I need to change all of my masters to mains. Recently, like everyone's been, a lot of people have been pushing to change all of your master branches in on GitHub and stuff like that to your main branch, which makes more sense. Like, obviously it's your main branch. You should call it your main branch. Like, it's like the only reason I know it's called the only reason I call it a master branch is because that's what everyone else calls a branch. But really, like, when you think about it, main just makes more sense. So I'm like, yeah, I should probably do that, you know? Okay, so what I'm going to do next is I'm going to cd projects flamify because I realize that now our convolution is actually incorrect, the convolution that we did before. So what I'm going to do is go into cd source, and I should have in here like a convolution image tools maybe. And let's do convolution, should be in here somewhere. Fractal convolution should be in here, great. Okay, so I'm going to do a quick to-do in here as well, just to say to-do, I believe this is actually a correlation, not convolution. Okay, I'm just gonna put two little carrots in there to make it so when I read this, I don't get angry. All right, so we're gonna cd project simuleos convolutions. Okay, so we have the right visualization. What I might do now is I might take a second and just do some algorithm archive PRs. Again, we've only been streaming for an hour or so, but I need to get some PRs done. And since this is a good breaking point or a stopping point, since I think the convolution is right now, we can hop onto the algorithm archive, do some work there, and then we'll get back to doing the convolution stuff after that. So in Canada, we have a 3-year bachelor's degree, but they are rare and don't qualify you for further degrees. Most people do 4-year programs. Yeah, I think the Canadian system is like a mix between the European system and the American system, but I'm not really sure. If you don't need to retake your courses from the year you failed. 3 years for bachelor's in Europe. Yeah, so the collegiate system is remarkably different in Europe than it is in the US. I had to do a few interviews for some positions in for OIST, and you know, we got some European applicants and stuff like that. And it was very difficult to like kind of rate. Like, if someone came in from Europe, I didn't know the European system, so I had to ask about it. And if someone came from the US, again, I knew that system, so I knew what like a good GPA was and stuff like that. Main and master are interchangeable in this meaning. The change was supposedly because of racial problems, which actually doesn't apply for get masters since it's not a master-slave thing. I decided not to make the change myself. That's fair. I mean, like, honestly, it's up to you, like, what you want to do with your own repositories. Like, totally fine. But, you know, I figure why not? Depending on the faculty, back in the 2000s, we had 4 to 5 year faculty. 4 to 5 years faculty. Polytechnical ones had 5 years, 6 years for medicine. Also, there were colleges, but it was like a short faculty scheme. Not all unis had it. Then I think 3 to 5 years doctorate. Then masters appeared for 1.5 to 2 years, and the faculties dropped 1 year to 3 to 4 years. 5 years for medicine and doctorates. I guess we're 3 to 4 years. That's what I remember. Do you know do you know Jacobian matrix and Gaussian kernel? A couple of days ago, I read an article in which they applied these calculations to the image, and I was lost in that part. Yeah, so I know Gaussian kernel, but I don't know what they mean by Jacobian matrix. So the Gaussian kernel is literally what we're doing up here in the upper left. So here, let me show you what the Gaussian kernel does. Let me just do that visualization now. So let's go into, where are we? Convolution.jl. I'm going to make y a Gaussian, and I'm going to keep x what it was before, which is just going to be a square matrix. So what I'm going to do now is I'm going to include and run main. So we have a big square, and then we have this Gaussian kind of coming over the big square. That's what we're going to have here. So if I do mirage out, I screwed up. I need to comment this out. And also, while I'm at it, what I'm going to do is I'm going to drop this to be 10. Okay, so now we're going to do include main, and then we should have something a bit nicer. Okay, now we're going to run mirage. Okay, so here we have, okay, right, that's what I wanted to see. I don't know, it's in the center. I know why it's in the center. Okay, so we have this kind of very sharp Gaussian, and if you look at the convolution over here, you'll see that it's kind of like the square wave. So here, let's just go all the way through. So it's kind of like the square wave that we saw just a second ago, but it's kind of like the edge is a little bit smeared out a little bit, right? So when we apply this Gaussian kernel to this little square wave that we get in here, what we end up getting out is something that's blurred a bit. So when you talk about a Gaussian kernel, typically what you're talking about is blurring the background of an image. It's a blurring operation is what you're doing. And again, the way that we're seeing that here in our 1D example is that the edge of this kind of square isn't as sharp as it used to be. It's kind of now a gradient of some sort. So that's what you typically think of when you think of a Gaussian kernel. Jacobian should only appear if there's a change of coordinate system. Also, don't even start talking about the French systems. It's really weird. So the thing is to make all the upper education standardized and to make the equivalence from one country to another easier. Most European universities adhere to the Bologna university system. I think that's fair. Like, again, Europe, I've made this claim a lot, and most Europeans disagree with me, and I know we have a lot of Europeans in chat, so don't be angry about this. But Europe to me, also the Kitty Slayer 7, thank you so much for following. Europe to me is essentially, okay, I need to say this politely, because there's no way to say this impolitely. But what I mean to say is that a lot of times European is like a federation of countries in the same way that the US is a federation of states in a way, right? Like it's the United States of America, and the European Union is a very similar system where you have a whole bunch of countries that are competing and are interacting with each other and doing what countries do, but there's still one overarching federal system or something like that, right? And so in order for this to work, you have to make certain agreements for like education and you know, things like this. And so it makes sense that everyone adheres to the same university system, because otherwise, you know, you can't transfer credits between countries very easily and stuff like that. Like, you know, you need that form of standardization and stuff like that. It's a bunch of countries with different languages and different... I mean, you're right that they have different languages, but really, like, I think... Okay, so this is actually what this is my true opinion about this, is that a lot of Europeans don't understand how divided the US actually is. Like, each state is remarkably different than the other states, right? Sure, we all share a common language, right? Kind of, like we're all mostly English. In fact, we don't really have a national language. But, you know, at the start, the US was a federation of different, essentially, countries, right? And, you know, the Californian economy is dramatically different than the Alabamian economy and stuff like that. And so, like, I feel like as someone from the US, it's very easy for me to look at Europe and be like, oh, it's just the same as what we have in the US, and that's a good thing. And then people in Europe will look at the US and they'll be like, oh, the US is exactly like France. But I kind of don't see the US as a single country, right? I see it as a federation of states, right? And that's why, like, for me as a US citizen, I don't tend to look at the US as a single thing. I tend to look at it as a group of other things, you know, in the same way that I look at the European Union as a group of other things, you know? You got it right. I think it's similar, but the EU is a much weaker federal level than the US federal government. Right. That's true as well. And the reason for that is, you know, pretty much because of the Civil War, right? Like, putting aside the slavery issue, at the end of the Civil War, I'm not saying I agreed with the South, just for the record. That's not what I'm saying. What I'm saying is that at the end of the Civil War, they realized that in order to make the Union work, they needed stronger federal support. And that was one of the things that came out from the Civil War, right? Because that war happened, the Union became stronger because it had to become stronger in order to reincorporate the Southern states. So that's kind of the U.S. history reason for why the federal government is now stronger. The EU is still very new and might be stronger in a few generations, right? And also then you have people like the UK who are leaving the EU, and when that happened in the U.S., a whole bunch of states went with them, and then we had a civil war. That luckily did not happen in this case, but I guess that's my point, right? Like, if people start to leave, you got to do something to bring them back. And I don't know. I don't know anything about politics. I'm just explaining what I understand from U.S. history as someone who took multiple classes in U.S. history as an undergraduate. That's the depth of my understanding here. The 1940s is really recent, yeah. Different values. Every country is independent. It's much easier in the U.S. Everyone speaks the same language, having the same history. Let's say have a federated leadership. EU is not a federation. Germany is a federation, for example. Switzerland is a federation. That's probably true. I mean, I'm probably not understanding the nuances to each country in a similar way as how I feel like other countries don't understand the nuances to the U.S. Probably I'm doing the same thing to other countries, right? Like, I know Germany is a federation of states because, I'm a Lutheran and I had to learn German history, and I don't know Switzerland's history, but I can imagine it's very similar. Can we also, I see, can we also use Gaussian kernel in sharpening the image? In the article, they used it in processing MRI brain scans. You can't, so the Gaussian kernel will always blur the image, but there is a way to deconvolve, which I don't know very much about, but deconvolution is a thing. So they might have tried to do the opposite of Gaussian kernel in the image or in the article. I really don't know. It kind of depends on what the article said specifically, and I don't know what article you're referring to. And also, don't quote me because I know nothing about deconvolutions. I need to learn about them. So that'll be another stream for another day. Okay, so let's take a quick break from doing convolution visualizations and just go to github.com. and take a look at the algorithm archive really quick and see if we can do a quick PR review, because there's 62 open PRs, and I kind of want to just start knocking some of them out. So here's domain coloring for Python using matplotlib. This one seems like something we could probably do. So let's look at files changed and see if there's, right. Okay, let's just run the code and see what happens. So also, let me open up domain coloring in the algorithm archive and see what we have. So I'm going to open up algorithmarchive.org -archive.org. There we go. I should probably bookmark this. Wonderful. Okay, and let's go to domain coloring here. Okay, so it looks to me like the code that we have for domain coloring, it has no... Okay, here's a full script to generate the domain colored output of f of z. So, right, let's just run what we have and go from there. As it blurs, it removes a bit of the noise, so maybe deconvolving Gaussian could be sharpening the image. Right, so that's why, like, for example, canny edge detection methods, like a lot of the ways in order for you to figure out what the edges of an image are, will start actually with a Gaussian blur before applying the Sobel operation and stuff like that. So the Gaussian blur is one of the integral components to edge detection, in the same way as image derivatives are and stuff like that. So, okay, so let's take a look at this PR, and then we're going to come back to convolutions after that. Just kind of, hopping around some different topics and, having fun with it. Okay, so let's go to the algorithm archive. CD projects, algorithm archive, ls here, git branch, git status, modified. So it looks like it didn't modify these guys. So let's go ahead and just add them, and I'll squash everything later. Git add contents, convolutions, probably star, git status. Looks good to me. Git commit -m. Adding a few more changes to convolution chapter. It's plural. All right, git push. Origin convolution update. All right, and now let's just take a look at what we have for domain coloring. So I'm now going to checkout master, git checkout master. Git pull upstream master. And yeah, so this has a few changes. Yep, to nim and stuff like that. So now we're going to cd into contents, domain coloring, ls here, and we're just going to go into cd code, ls, and now we're going to go into cd GNU plot, ls, and let's just run GNU plot, domain coloring.gp and see what happens. I don't actually know what this will do because it's been a very long time since I did this. So hopefully this outputs a very simple domain colored, you know, f of x equals x squared image. It should be pretty pretty to look at. If it doesn't, it seems to be taking a while. Okay, there we go. So let me do an ls here, and let me just open up Mirage domain.png. Okay, so this is the image that we want the Python code to look at. So for those of you guys who maybe weren't here for the domain coloring saga, it was a few months ago. I understand that you may not have been here before. What we're looking at here is a particular image that is in real space on the x-axis and imaginary space on the y-axis. And the idea is we're plotting a very particular function, which is f of z is equal to z squared. So what happens is the phase of the image will actually change by 4 pi. So it wraps around the center of this image twice. So that's why you see red on both sides here. And so the idea here is that we have this colorful rainbow of effects that wraps around twice. And if you want to, why is everyone saying wow? Wow. If you want to learn more, I do have a video and also the algorithm archive chapter available here. So let me just do yank capital Y and paste that here. So that's the algorithm archive article. And I believe we also have a video. Yeah, we do have a video available here. That's an ad. Just shut up. Don't want to talk to you right now. Yank, yank, and paste that here as well. So if you're interested in learning about those are available there. So let's go ahead and grab this. And I think as far as the code's concerned, it looks relatively clean. I'm relatively happy with it. So let me just go ahead and take a look at the conversation here, grab the branch, and see what we can do. So command line instructions, git checkout, perfect. Okay, so this is the image that we want the Python code to output, something that looks like this. Okay, so let's just go ahead and pull the branch. Perfect. Yep, sure. All right, cd back, ls here, cd python, ls, and let's just run python domain coloring.py. Took way shorter to run. Let's look at mirage domain.png. Okay, it looks good to me. That is the exact same image. So now we just have to look at the file to make sure that there isn't any. Oh, it is a bit smaller though. It doesn't matter, it's fine. So now we just have to look at the code just to make sure there isn't anything weird going on, but it's Python. You know, how can you can't screw up Python, right? Like, I say that, but I've definitely screwed up Python before. You guys did not see the code for some of my early visualizations on YouTube. It was pretty bad. Okay, so the code runs. We're gonna have to build the algorithm archive just to make sure that it looks nice. Let's cd projects algorithm archive, npm run serve. I have far too many channel points, so I did this too. You can't screw up Python. One indent later. Yeah. You're right. You can easily screw up Python. I've definitely screwed up Python many times before. I feel like, okay, the Simul Wow emote is one that, like, it's been growing on me. It has definitely been growing on me recently. Open, paste, perfect. And let's take a look at domain coloring, and we should be able to switch this to Python and matplotlib. Should be fine. Scroll down. Ooh, okay, apparently I cannot scroll in that way. How do I? Come on. Okay, well. There is a bar on the side, but I can't scroll by clicking on the bar. Okay, let's look at the code. Yeah, it looks great. Okay. So let's see. We have defined color, magnitude shading, grid lines, f of z, color, name, axis set, title, clear. I mean, this looks good to me. There isn't really anything really. Yeah, this looks fine. I'm happy with that. The only thing is there's like a weird space up here. Is that also true in GNU plot? Or is there just a space in the code? Should I ask him to remove that space? Or should I just go with it? Actually, never use Python because I demand to be able to refactor without any special editor support. Wait, why can't you refactor in Python without special editor support? Life's too short to have to re-indent yourself. Oh, I see what you're saying. Yeah, yeah. I'm happy with this. I think it looks pretty good. So I'm going to go ahead and review changes, approve this guy, and just say the code runs. すみません。でも I'm using the Qt browser, so I have to press I to insert first. The code looks good. And creates the appropriate image. I am happy to merge. All right, submit review. Now I believe he's not a first-time contributor. He's definitely contributed before. Yeah, so he's contributed before, so this should be fine. So we will squash and merge that guy. And we're good to go. So that's one PR down, only 61 left to go. There's another PR that I put out that I think should be able to merge, like we should be able to merge it pretty quickly, but I was hoping to get a review from Bergquist before doing this one. So this is just switching to GitHub CI, because right now I don't believe we're actually updating the site on merging. Let me just go here and check that out. So algorithm archive, algorithmarchivist.github.io. Oh no, it's still deploying. Okay, that's fine. But we might want to switch to GitHub CI later. What are your thoughts on Julia? I mean, obviously, I've drank the Julia Kool-Aid. I'm a fan of Julia. It's one of those languages that, as someone who does scientific computation, that's the bulk of what I do. Julia is fast for what I need it for. Admittedly, precompile time kind of sucks, but whatever. I can take that. And it's easy to read relatively compared to other languages. In fact, I feel like the syntax for Julia is easier to read than even the syntax for Python, for example, in my opinion. That's definitely true. Don't ask me about MATLAB, boy. Yeah, no, I'm not going to talk. MATLAB is not, I'm not going to do MATLAB. You have to admit it has a cool name. Yeah, I think the name Julia is also quite nice. The problem is, like, if you Google Julia, that was not what I meant to do. Oh, no. Geez. Okay, let me just do twitch.tv/Simuleos just to have this up in the background. And I will mute myself. Perfect. Move this over here because I just like having my stream up in the background. Okay, cool. Okay, so that's that. So we have a PR down. I think we can go back to convolutions now. And yeah, that was a nice side tangent. Git pull, upstream master. Okay. Oh no, what did I do? I'm dumb. Git checkout master. Git pull, upstream master. Oh boy. Okay, so now git branch. Let's just remove some branches that we don't need really quick before moving back to it. So we don't need this guy. Gomen. Git branch -d. This guy. We also don't need this guy. And let's see, anything else we don't need? I think that's okay for now. We probably don't need flood fill or flood fill fix. Monte Carlo fix. Anyway, so CD projects, Simuleos, convolutions. One more thing, do I need to update the docs for the PR? Because I didn't. Wait, update which docs for the PR? Okay, so if you're submitting code, if you're submitting code, there's a few things that you need to do. One of them is to actually submit the code, but the other thing is to make sure that the code is linked to the algorithm archive chapter. I submitted the code. Wait, which PR are you? I'm sorry about that. Exegetty Chris, thank you so much for following. Really appreciate it. Sorry, I'm so bad at names here. So let's go to github.com. The next one. Let's see. Got algorithm archive. Pull requests. I think you're still redo on this, aren't you? Oh, are you the one to go? This one. Perfect. Okay. So what needs to happen here is, okay, you are right. So there's one thing that you have to do, which you didn't do in this PR, and that's okay. So if you're adding something for iterated function systems, what you're going to have to do is cd projects algorithm archive lscd into 1 second. I'm thinking contents, iterative function systems, lsvi iterative function systems.md. And essentially, anytime you see this method, method, one second. Oh gosh. So anytime you see begin and end method in here, so let's just look for method here. So we have method here. We had it up here. So 1, 2, 3, 4, 5, 6, 7. Okay, actually there's only 2. I'm just dumb because if I set number, sorry about that. So if I set number, I think there's only 2. Yeah, so there's only 2 places, but you just have to make sure that this looks at the appropriate lines in your code. So for example, it's lines 4 to 17 in Julia, 39 to 52 in C++, stuff like that. And then down here, you don't need line numbers. So you just have to modify the code in these 2 places so that when we build the book, it has the code in the right spot. So that's all you need to do for that. I say all you need to do. It's still kind of a pain. We do understand that it is kind of a pain to submit. But also, yeah, we need more Go reviewers. So if you know Go, please, please do some reviews. I'm sorry, I'm like begging people to do reviews, but that's kind of, we need it. Like we have Coconut, we have OCaml, we have Scala, we have Rust, we have Node. Oh, geez. We have PowerShell, we have JavaScript, we have Python, we have all these languages, and I can't review any of them but Python. So if it's possible, like, to do reviews of other languages, if you know any of those languages, feel free to go to the algorithm archive and just check to make sure that those implementations in those languages make sense. That's all I need. I don't need to look at the algorithm. I can look at the algorithm. I just need someone to look at the code and be like, this code looks clean. You know, that's it. Okay, so we're gonna close that, and we're gonna get back to convolutions. There is a language, Cow. Have you heard of it? I have not heard of it. But if you want to submit something, you have to get someone to review it as well. So I guess that just means if you're going to submit code to the algorithm archive, you should submit code in pairs, like someone to actually write the code, someone to review the code. Okay, so we're going to CD projects, Simuleos, and Convolutions. Ella's here. I think actually I'm good to go with the 1D visualizations, actually, now that I think about it. I think that, okay, now I'm gonna open up a new terminal because I'm just hopping around too much. Let's see what we actually need. So let's move over here. No good, Nick. Thank you so much for following. Really appreciate it. Codes are something like moo, 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 moo. It's a nice language. I wrote a JavaScript interpreter for it. Oh, wait. Oh, okay. Something like this, maybe. Are the methods in Markdown sorted in any way? I see first one is Julia's and CPP. It doesn't have to be sorted. No, it's anything is fine. Yeah, nice. Oh man, there's so many esoteric languages. So you have tests for implemented algorithms. For example, if I review an algorithm, should I ensure some tests pass? Yeah, so the example, every algorithm has an example that you're trying to follow. So for example, with the one that we just reviewed, we had to make sure that a particular image was produced, and the image was shown in the chapter. So at the end, let me just go to here, again, algorithm archive .org, and we just go to anything here, like maybe Monte Carlo, for example, and we just scroll down here. It says here exactly what you're supposed to be replicating. So here you're supposed to be integrating and trying to find the value for pi, right? And that's what this does. So it should output pi. So again, they're not quite unit tests. You guys are correct in saying that they're not quite unit tests, but they're a simple test just to make sure that it passes and that the code does what it's expected to do, you know? So that's where we're at there. Yeah, again, I'm a big fan of the esoteric languages, but I just wish, I wish more people knew how to like review them, you know? CD projects, algorithm archive, L is here, git checkout, convolution update, here should be fine, and then git, npm run serve. Okay, so we'll take a look at this local build of the algorithm archive, and we're gonna see what we actually need to update for the convolution visualizations, like which visualizations we need. I think we're pretty close to what we need for the 1D visualizations, but I'm gonna check that, and then we're gonna make those visualizations and get that chapter done. Mostly done as we can for now. So let's do this, open up this, and then we still have a few more things to do, and we'll talk about what's left to do from there. Whitespace is also very cool. It has more powerful operators than BF. Yeah, so if we actually, I think, have bubble sort in Whitespace. Whitespace, no, must be the Euclidean algorithm then in Whitespace. Yeah, here it is. Here it is in Whitespace. Admittedly, there's something wrong with the way that we're hosting the code makes it so Whitespace isn't visualized, which is why down here we actually have space, line finish, all this kind of stuff. So it explains what's happening down here. Because we couldn't figure out how to get it to work otherwise. Anyway, so let's see. So for the Convolutions chapter, my intention is to have just a brief intro about convolutions, talk about convolutions in 1D, and then move on to talk about convolutions in 2D. And so here we want to talk about the Gaussian kernel, the Sobel operator, and stuff like that. So I think today, again, we've got 30 minutes. I think we can finish up the 1D chapter today. And I think the goal is to finish up the 2D chapter tomorrow. So we have 30 minutes until 6 o'clock, which is normally when I start stream time. And then I actually will be continuing streaming from 6 to 8 p.m. today. And the goal is to also maybe there's a bunch of other things that we can do at that point. But I think let's go ahead in the next 30 minutes just because that's a nice time to just kind of wrap up what we're working on right now, finish up the 1D visualizations, and then we'll do 2D tomorrow. I want to take a step back and kind of flesh out these sections for tomorrow. And then hopefully by Wednesday, if we just kind of hammer it all out, we can get the, what was I going to say here? 1 second. We can get the Convolutions chapter basically done. And then we can go from there. Vim has a plugin for syntax highlighting in whitespace. Oh, really? Maybe we could format it like this. Yeah, let's see what this is. I believe it goes to down there. Over here, paste that there. Okay. It'd be good to format it like this. I just got to JS. Oh no. There's so many esoteric languages, it's crazy. Rate this life-changing. All JSF code is valid JS code. Interesting. They have only 3 possible rates: life-changing, helpful, and unfulfilling. My life is definitely on the unfulfilling end of this, but I like to be helpful sometimes, but definitely not life-changing. Anyway, okay. So convolutions in 1D, what visualizations do I want to make? I want to redo this visualization. Then I want to modify our triangle visualization and do the visualization we just made. So let's just fill in those visualizations we have. And then I think I might also update the chapter as well. Are the import numbers inclusive? Import 2744, include lines 27 and 44? Yes, I think it does include 44 as well. But actually, if you can just go ahead and push it, I can build it and I can tell you whether it worked or didn't work. You can also build it on your own machine just by running npm run serve in the main directory and just checking it out. But obviously, I understand if you just want to try something, and I can try building it on my own machine as well. And we can do that here on stream. Okay, so this is about what I expected. If I remember correctly, it does. Yeah, I think it does. Okay, so let's go ahead and build these visualizations that we need. The first one is just going to be redoing this Gaussian visualization because that Gaussian visualization is now incorrect. So let's go into vi convolutions.jl, move down here, and let's get that convolution visualization done. So we're going to do that, comment this out, comment that out, and actually I'm no longer going to normalize x and y, there and there. And I believe that's what we need. Let's go ahead and dd the print line. Let's go over here and let's just run include and then run main. See what this does. npm bash, npm command not found. Yeah, so you need to install Node.js. That's true. Okay, so let me do Mirage here. And that Gaussian is very small. Try this one more time. Over here, change this to 100. Okay, try this again. Convolution. Main. Try that. Oh yeah, whitespace is whitespace is probably my favorite esoteric language. I mean, don't get me wrong. Okay, never mind. My favorite esoteric language, you guys are just hear me out for this one, is actually one called placement. All right, you guys, you're gonna love this one. Like, if you guys haven't heard of placement, you're gonna love this one. Okay, so you guys know brain brain F. I'm not going to say it. You guys know what you guys know what language I'm talking about. Like everyone knows what language I'm talking about. The one with a curse word in it. Right. So this is that language, except that the only way for you to implement each character in that language is to go to a physical location on Earth. That is to say, somewhere between some longitude and some other longitude, right? So to implement, each of these characters, you're going to have to go between these areas, right? So the only appropriate way to code in placement is to actually go to the North and South Pole and run around the pole, right? That's how you have to do it. So the interpreter is connected to a GPS and accepts only 3 commands: exclamation mark, question mark, and colon. Colon clears the program in stored memory. Question mark runs the program stored in memory, and exclamation mark appends a BF character to the program depending on the interpreter's longitude. My favorite coding language. I love it so much. No one has actually effectively written "Hello World" in this language. If anyone were to fly to the North Pole, they could be the first to implement "Hello World" in this language if they were to fly to the North Pole with an appropriate interpreter in hand, like some sort of GPS in their hand, which would be kind of fun. But also who's gonna fly to the North Pole to get it implemented? But yeah, so that's my favorite one. White space is my second favorite one. Okay. Take a look at the visualization. What do we have here? Mirage. Should be fine. Yep. And it should keep going all the way to the end. Perfect. Okay, so this should create a nice, consistent, nice consistent image. Let me see if we have the last ffmpeg command in history. History grep ffmpeg. Oh, it's definitely an esoteric language, no doubt. Ffmpeg. I don't have it. Okay, that's fine. There was a particular flag that I needed to use, but I don't remember what it is. So there's Malvolg. That's just the most esoteric language I can think of. Incidentally, the creator of Whitespace also made Idris, which is a pretty nice non-ESO language. Interesting. Fair enough. Okay, so let's go here and let me just do ffmpeg, series of images. There's some sort of flag that I'm supposed to use, and I don't remember what that flag is. It's like, YUV420p. That's what I was looking for. Great. So I'm gonna pretend I understand ffmpeg. Let's see what happens. ffmpeg, input, output, 05d. .png, YUV420p, and then I think I can just do the output. Let's do out7.mp4. Gah! I was close. YUV420p. What did I write? I did write YUV420p. Oh, I need PIX format. Of course I need PIX format. I was close. Yeah, okay, so now let's just do, actually, let's go up here, close this guy, and let's try a new visualization. Let's do out7. What did I did call it out7, didn't I? Oh, let's see what happens. Wow, look at that amazing visualization. It's the exact same one we had before, just going in the other direction, but actually correct this time. When you mentioned white space, I could only think of black holes being lost in the nothingness. Speaking of black holes, okay, so you guys know how I helped work on that MIT course 18S191 on computational thinking last term, right? One of the coordinators for that class really wanted to see a black hole visualization. And I was like, there's no way we're going to see a black hole visualization. It's just not going to happen. And they were like, yeah, but we could. And I'm like, no, we can't. It's too hard. But anyway, it's fine. We did our best. Honestly, I think the course turned out pretty well. But even so, it was a lot of work. There's a crazy Clash of Code gamer, not me, who wrote a whitespace interpreter in Ruby and solves the 15-minute Clash puzzles in whitespace sometimes. Huh. Interesting. That sounds super fun. Okay. I have way too many terminals open, which is not something you'll usually hear me complain about. Usually, I complain about having too few terminals open. So what I'm going to do is I'm going to make this default sized, and I'm just going to throw it down here in the lower left-hand corner where you guys can't see it, because this is just going to be constantly running the algorithm archive, and there's really legitimately no reason to have you guys see it. So we're just going to have that sitting there. And now I'm going to open up another terminal, which I'm going to make huge. And we're going to move that over here. Okay. What Windows Manager is this? This is OpenBox. I think if you just go distro, I think it'll maybe OS. Maybe it was OS. I've updated the pull request. I just saw the email. I'll do the pull request in just a second, so I'll check it out just to make sure it builds and it looks good. So let's now do CD projects, algorithm archive, contents, convolution. Oh, hello. Convolutions, ls here, cd into resources, ls, and let's just cp project simuleos, convolutions out7.mp4, and we're going to call it 1D Gaussian animation.mp4. Now what I'm going to do is touch the, well, actually, let me just Control C and rebuild the algorithm archive just to make sure that visualization appears on the site. Give it a second. I think R is to refresh. It is, but there's nothing to refresh to, so, you know. Cool. Okay, so this visualization should be the correct one. If we play it, yeah, nice. Okay, and it should just keep going, I think. Yeah, it does. Wonderful. Okay, so now the next thing we need is a set of images. So here we're going to do that triangle and square wave visualization. So now we have to get that triangle and square wave visualization actually working. So let's do that. Don't know what I was doing. Don't ignore me. Sometimes I just think I'm in Vim when I'm not, or VI. Okay, so let's do the square wave visualization that we have. And then let's talk about what we need to do to make that visualization actually look good. Okay, so we're going to do, let's just go ahead and DD here and paste this up here. And now we're going to do X, yeah, and comment these out up here. Perfect. Write this, go over here. Is this something? One of these terminals. Oh no. How many terminals do I have up? On this screen alone, I have 1, 2, 3, 4, 5, 6, 7 terminals, which is fine, totally fine. But also, like, I should do better at terminal management. All right, so we're going to include this again, and we're going to run main. And we're going to take a look at that visualization, and we're going to fix it from there. Wonderful. So now we do Mirage. Okay, so here's a triangle. The triangle is clearly too big. Right. Yeah, okay. That's kind of what I expected to happen. So the issues that we have right now is that, the issues that we have right now are that, plural, trying to speak English. The convolution is just way, way taller than anything else in the image. So how about we modify this a bit? So what I'm going to do now is I'm going to, I am going to open up this terminal, and instead of doing a normalization, which is what I was doing before, I'm actually going to make it so this is, it's going to be this divided by 20. And so let's just put this in parentheses there and here. And in principle, this should almost solve our issue. So let's do include main. Let's see what this does. Hey, Trash Talk, how are you? I hope you're having a wonderful day. Okay, so let's take a look at this visualization. Mirage. Okay, so now the triangle and square are almost the same size. We go up and down. Okay, so now the convolution looks really small. I guess it's fine. See, the convolution is scaled based on the, like how big the signal is in a way. So what I might want to do, I can just multiply this by 2 or something like that. The problem is, maybe I should fix the other visualization as well. So because, okay, maybe I should change it so it doesn't just say convolution. It says scaled convolution or something like that. Maybe that's what I do. Yeah, maybe that's what I do. So let's change that visualization we just had also as well. And we're just gonna say scaled convolution, and we're not gonna worry about it. Filter area under, and here we're gonna do, oh, I have the output name. Let's change that to scaled convolution and let's see what it looks like. Okay, so we're gonna go over here. We're gonna run include main, give it a second to run, see what it looks like. And now let's take a look at the output. I think that looks fine. I mean, the box is too big. I mean, no matter what, that box is too big. It's still covering information, but it's not a huge deal. I finished an assignment due tomorrow, so that's cool. Good job. All right, let's run that again. So we're going to quit here. We're going to run ffmpeg out 7. Yes. Open up this terminal, CP it over, and then we're going to do it again. Convolution.jl, move down here, and what we're going to do is modify this so comment that out, comment that out. This is now divided by 19 instead of divided by 20. Okay, and then over here, what we're going to do is we're going to multiply this by 0.5. I believe that's what I want. So we're going to include, and now we're going to do main, and see what this looks like. And watching James code is always fun. I'm mostly listening in. Well, hey, I'm glad you guys are here. So let's take a look at Mirage and let's see what this looks like. That looks pretty good, I think. I feel like we could... I feel like we're off. I was hoping that watching on a phone is kind of hard. Oh, hello. Hello. What's going on back there? Okay, we'll just... Okay. We'll just kind of close that. Try that one again. Okay. That was my bad. Okay, let's take a look at the image again. Here. Make that a bit bigger. Watching on a phone is kind of hard. Yeah, sorry about that. I thought typing is hard. A lot of things are hard. Just because one thing is hard doesn't mean other things are easy. Okay. So... I thought the area of a triangle was 1/2 base times height. That's what I thought. But, yeah, I mean, I realize the text is a bit small. There's just a lot of text to be on screen. I get that. I mean, again, there's probably a way to fix it. I could get a second monitor, and I could have, like, one monitor specifically for, like, code. I tried to fix it one time on one of my live lectures, and it just failed miserably. So now I'm, like... kind of worried to try to fix it again, but I could try to make it so the text is bigger, and like I switch between. I've been trying to think of how to do this, but I haven't quite figured it out. But you know, maybe I should think about that as well. Okay, so for some reason, this doesn't go all the way up to 1. I expected it to go all the way up to 1. So what I did is I read in. I've been watching like this for more than a year. Yeah, that's fair. I mean, I guess most people don't care, but I do think it's one thing that is kind of holding back my stream in particular. Like people can't read it. You know, they get mad at the, you know, syntax highlighting, this kind of stuff then. You're a pro then? Sorry. Okay, so... what I tried to do is I tried to scale the convolutional output based on the highest possible value for the convolution that we get. Now, the issue with that is that... okay, so I want this to go all the way up to 1. So the sum of... oh, I see the problem. Ah, I see the problem now exactly. Okay, try this again. So what we're going to do is we're going to say this goes from 20 to 0. And now we're going to divide by 20. And we're going to try that again. And we're going to run include main, and then hopefully this will do it. The triangle is narrower than the rectangle. It seems like it would be the reason. Yeah, I just noticed that. Thank you. So let's take a look at that. I think that actually was the reason. So let's make this bigger and just see what we got. Okay, so we're going to scroll. Ooh, hello, Mr. Me. I did it again. Try that again. So here we have it go all... there we go. It goes all the way up to 1. Drops back down. Wonderful. Perfect. That was exactly what I wanted to see. Great. So we are going to turn that into an image. Put your cursor on 20 and press Control X and Control A. Control X. What do these do? Put your cursor on the 20. on the 20 here, and then press Control X and Control A. Okay, so Control X, Control A. What does that do? It crashes your machine? What? I don't think it crashed my machine at all. Increments and decrements the number. Does it? Control X, Control A. I don't know what, I just tried it. I have no idea what it's doing. In VI. Wait. It crashes your machine, increments and decrements the number. Oh, I see. Control X, Control A. Ah. XA? Maybe that only works in Vim. G. Control X, Control A. Ah, so interesting. That's really cool. Didn't know that. Thanks for the tip. Okay. It doesn't work in VI. It only works in Vim, but that's okay. Output 8.mp4. That looks good to me. Yep. Okay. So now we're going to put that into the chapter. So let's go into VI 1D and then 1D.md. I'm going to grab these lines in here. So 1, 2, 3, 4, 5, 6. So yank 7 yank. Anim. Paste. And I guess I call this 1D Gaussian animation. So I'm going to call this 1D triangle animation. Okay. And what I'm going to do next is I'm going to do this and do 1D triangle animation and do out 8.mp4. So we'll do triangle animation. Write that. Ah, you kidding me? Move 1D triangle animation. I put a W in there because I thought I was in Vim to 1D triangle animation without the W. There we go. I tried to write it. Like, because of course, I thought I was in Vim and I just tried to press the W like you always do. Okay, I'm going to build it again, see if the animation works, and then I'm going to add... In fact, I don't think I need the images anymore. Let me read the chapter. Okay, so here we have these guys, and then I say add him. Demo. Soka. Ne. Let's do MPV. MPV 1D triangle animation.mp4. Okay, it's there. That's great. Okay, so then the question is, where is it in the file? So let's go here. Triangle. Probably just misspelled it, right? Yeah, pretty sure I misspelled it. 1D triangle animate. That looks right to me. Right? Okay. L is here. 1D triangle animation.mp4. Animation. Right. 1D triangle animation.mp4. Am I dumb? Don't answer that. I know the answer to that. But am I dumb? Okay. So what's going on here? 1D triangle animation.mp4. That looks like the right name. I must be, okay. 1D triangle animation.mp4. Check the mp4. Okay, let's move up here. 1D triangle animation.mp4. That DT here. Paste it there. Right and quit. Control C, rebuild it. MPV. 1D triangle animation.mp4. Yeah, so I did run it, and it runs fine. Like, the video is working. So let's just rebuild the site and see what happens. Have you ever tried engineering cellular automata rule set? I have not, but I did think a lot about doing that just recently, last year. I thought it'd be a good idea, but we ended up not doing it in the end. Let me refresh the page. Maybe that's what we needed to do. Scroll down a bit. Ah, okay, it is there. I just had to refresh the page. Okay, so if we run this, we have it go up, back down. It should loop. Okay, that's fine. It loops in kind of a weird way, I think. 25 FPS, European standard. Wait, what? I have 25 FPS? Oh, wait a minute. Oh, the video is in 25 FPS. Yeah, okay. I don't know. Sorry about that. I don't think anyone really cares about the FPS of that particular visualization, right? Okay, so I think that's all we really need for today for the convolutions. I think we can do something else for a bit today. So let me do this really quick. I have to send a message to someone. I'm sorry. Confused PCMR noises. What is PC? Oh, PC Master Race, right? 1 second. Okay. Do I have any other messages I have to respond to? I think I'm okay. It's important to the cinematographers and a bit of YouTubers. I think, yeah, probably, maybe, yeah. If someone wants to use one of my animations for their YouTube videos, which has happened before, they're just gonna have to deal with the 25 FPS. Are you Welch Labs? I'm not Welch Labs. The Abdullah Amar Saab, thank you so much for following. Really appreciate it. No, I'm not Welch Labs. I'm my channel is here. YouTube. So that's my channel, Leos OS. Welch Labs though is an amazing YouTuber, and definitely check out their content as well. Honestly, they're super good. He is Banksy Fun Fact. Who's Banksy? Who is Banksy? Should I know Banksy? Chotamate Banksy. Who is this? I thought you were him. You look very similar. I guess I appreciate that. I don't really know. I don't know what he looks like. Should I know? Should I though? Like, is this something I should know? Is a pseudonym pseudonymous? I've never heard that word before, but pseudonymous, that's fine. England-based street artist, political activist, and film director, active since the 1990s. Huh. Interesting. It's just the most famous artist in the modern time. Okay, I'm sorry. You guys did the same thing yesterday with mathematicians. You were like, do you know this guy? I'm like, no, I don't know this guy. I'm so sorry. Like, I've heard the name. I don't know who it is. I'm really sorry that I'm like such an uncultured, American person. What is it? What are they famous for? His satirical street art and subversive epigrams combine dark humor with graffiti, executed in a distinctive stenciling technique. Cool. Most famous artist, let's be fair. Okay, so let's see, who was it? It was Radu, I think, just pushed something. Let me just make sure that what he pushed, or they pushed, I'm sorry, I should not assume gender. Let me go here, and let's do github.com, and let's just go to the algorithm archive, and let's just make sure that the push here actually had appropriate formatting. Most famous graffiti artist in the UK. The girl with the balloon? Is that what this one is? Do they have a balloon? No, that's not a balloon. I am not seeing any balloons. Okay, I'm done. I'm sorry. Okay, so what I'm gonna do now is grab this locally, just to make sure it builds and everything, and then we can go from there. 1 second. CD back a couple directories because I feel like it. There we go. Perfect. Oh no, I modified a file. Now let's just do git stash. Should be fine. And then we're going to do this. Paste that. Do that. Sure. Right quit. npm run serve. And let me go back over here. Okay. Let's build, and we'll just make sure that the formatting is correct for this PR. Okay, so then the next thing we want to do. So I'm gonna leave what we do next up to you guys, because I'm actually, I don't know, I'm interested to see what you guys want to do. So let's take a look at this. Move over here. This, that, paste, and it was iterative function system in Go. Iterative function system should be able to go here to Go, and it should be that all the code changes. So we should see just 2 places here. Function chaos game looks good to me. And yeah, that's great. So it looks like it works pretty well. So at least the formatting is correct for the algorithm archive. Now I don't know about like the code, although the code does look clean to me. The issue is I don't know Go, so I don't really know if I can. Actually, it looks pretty clean. I'm pretty happy with that. But for me, I'm happy with this. Girl with the balloon. Yeah, let's see. Oop, hello. What do we have? I feel like I should have seen this piece before. How do you go back? Reload. How do you go back in the Qt browser? Hint, close tab, next tab, previous tab, scroll right. What is, how do I go back? I'm sorry. Like back and forward. Forward, back is capital H. So capital H, that makes sense. Capital L goes forward. Nice. Okay, that makes sense. He sold the painting with it for 1.4 million, and the painting shredded itself at the auction. Oh, right, that was Banksy. Yeah, I saw that. That was like a viral video. I definitely know what you're talking about there. Okay, so increase the value even more. I'm not really sure how that works, but I don't know. Probably. Art is one of those things that I wish I understood, but I don't. Like, you know, I can look at things and be like, oh, that looks pretty, but like, that's very far from what people like would consider to be, you know what I mean? Like, high-end art is something I don't think I'm ever going to understand. Let me just do D, 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 D. Wonderful. Okay, so let's go back over here. Again, we're doing the formatting was fine on that one. So now we're gonna do get checkout, convolution update, and now I'm gonna do get stash, apply. Looks fine to me. Good. High-end art is just used for tax write-offs. The painting stuck at the middle. It should have shredded totally. The half-shredded piece was still sold. Fair enough. It's still worth a ton. There's nothing to understand. Sad but true. I feel like that shouldn't be true, but maybe you're right. Maybe it is true. Maybe that's just the world we live in pays a lot of money for things that people don't need to pay money on. I guess that's fair. Like, I mean, if I was a wealthy elite, I guess I would probably try to find something that I could sell. I don't know what I'd do if I was a wealthy elite. Probably what I would do is, I don't know. Like, I can't even get in the headspace of someone that would just buy a painting for, like, whatever. You'd stream algorithms 24/7? Whoa, not 24/7. Maybe 8 hours a day, most. Banksy does stencil art. You can make your own for $20. I don't want this to be true, but it's mostly true. I feel like that's exactly my problem, right? Like, if you're just looking for a piece to make a room look better, you know, to kind of like, I mean, what is the point in a painting? I would argue the painting's purpose is to elicit some sort of emotion, in particular, emotion that is meant to exemplify or like be found when you enter a space, right? Expensive art is stuff is money laundering. Yeah, maybe that is what it is. But like, so I would argue if you're just trying to find a painting, which most people, if people want a painting, they're probably just going to put it up on their wall as something to kind of like bring the whole room together. You're not going to want to buy like super expensive art. You just don't want to do that because buying super expensive art is like, it's just, why? Like, you could draw something on yourself, or you could, because usually you probably want abstract art anyway, or you could buy something for at most $300, you know, $500 might be upper end of that, you know. Expensive art stuff is money laundering. Art shouldn't be so elitist and so wrapped up with monetary value, but it is. I mean, that's just life, right? Expensive art could be an investment. That's true as well, right? Like, if you have art from an artist that is, like, maybe they are, like, you know, they're a famous artist and, you know, they've recently died or something like that, you can probably bet that their art is going to sell for more in a few years. So I could see that being useful. Okay, so what I've got to do now, I've got a few things that we could hop into. So I think we have the visualizations for convolutions basically done. At least high art, the stuff you see in museums. Right, that's true. Yeah, I agree with you there. Okay, so let's open up Zernal PP and let's just outline what we could do now. And there's a lot of things that we should do. Like, I just don't know which one we want to do in the next few hours. Let's open up Zernal PP. Okay, so we're in private collections. Move that over there and that over there. Great. Okay, so right now we have the 1D convolutions kind of sort of sussed out. Tomorrow morning before stream, I'm going to take some time to finish writing out the article for the 1D chapter, and then also finish up the 2D chapter as well, or as far as I can get. And then tomorrow we'll come back and start working on those 2D visualizations. And then again, I'm hoping by the end of the day on Wednesday, we have the convolution chapter wrapped up. And I think we can do that relatively straightforwardly. Now, what do we want to do next? That's a good question. I've got a few ideas of things that I need to work on. Whichever one we want to work on, we can work on that. There are people who buy art from new artists and help them start out, hoping at one point they will become famous. Yeah, there was a game. It's called Passepartout or something like that. That was played by Jazza, and it was actually super fun. I don't know why, but I really enjoy watching Jazza. I don't know if you guys know this guy. He's a YouTuber, but like I enjoy watching him for some reason. Like, he's just a stupid artist YouTuber. He's not stupid, but you know what I mean? Like, the channel is not something that's like particularly mentally engaging or something like that. It's just, as you can see, I've watched all of the videos to some extent, except for this one, because it was with someone else. And I was like, I don't know if I want to watch it with someone else. I don't know. Also, do you guys get that vibe as well? Like, when you watch collaborations with people, I tend to click off of the video the moment that, like, I see a collaborator in the video. I don't know if that's just me, but I do that a lot. And I think I've realized, like, it's social anxiety that's doing that for me. Like, I know it's weird. Like, why would you be socially anxious about, like, why would you be socially anxious about, like, some guy you've never met on the internet? But, like, there's something about seeing a new person that I'm like, I don't really have the mental energy to learn about this new person. And so I just kind of click away, you know? And, like, I know there are, like, collaborations that are done super well, but just recently, anytime I see a collaboration on YouTube, I'm like, I'm just not interested. I don't know why. I can't get myself interested in it. I'm the same way. Okay, so at least I'm not alone, you know? Tribeca, you and me, people who are too socially anxious to watch collaborations on YouTube. Okay, so I'm going to commit what I have right now for this particular. I just assumed that your reasoning for clicking off was the same as my reasoning, which is probably not true. So we're going to cd into contents, convolutions, ls get add dot, get commit, get status first, get commit dash m, adding triangle visualization for 1D, get push, origin, convolution update. If you already know all the people involved, it's way easier. Yeah. I guess that's true. Like, if it's a bunch of science YouTubers, I'm like, yeah, that's fair. I hadn't really thought about it, but maybe. Yeah, I don't know. Maybe I put too much thought into it. Probably it's just I didn't want to watch the video because I didn't want to, you know, usually you think that collaborations are a bit, it's just a different style of video because there's more people there, you know? So because of that, you probably just didn't want to watch a video in that style. How's the work at MIT going? I will not be working at MIT as of tomorrow. Tomorrow is my last day working at MIT. So pretty excited for that, and we'll see what 2021 brings. It's going to be an interesting year. That's all I have to say. 2021 is going to be a very interesting year. Okay. I'm no longer at MIT as of tomorrow. That's like, tomorrow's my last day. So, okay. So let's talk about what needs to happen. Let me just go ahead and close this, and we'll see what we want to do in the next few hours. Wow, congrats. Yeah, I don't know. It's like, it's such a weird thing because, like, I know in principle I should love, like, the whole thing that happened with MIT just burnt me out, and I was just really frustrated. And I just realized, like, I don't need to stay there. You know, I can go, and that's what I did. I just left. My contract was ending. My contract is ending tomorrow, and I just decided not to renew it. Now, I'm still in Boston for the next 9 months, so I'm still paying super high, like, rent fees and all that kind of stuff. But for the most part, I think leaving MIT was a good idea for my just mental, psychological well-being. And also, like, in terms of professional interest, I feel like it's a good thing to do. I feel like, right now, I feel like it's the right direction. In a year, when I'm, like, homeless on the side of the road, I'm gonna be like, oh, that was the worst idea of my life. But right now it's okay. Did you get rid of the cockroach apartment? I did. I'm now in another apartment, which luckily does not have any bugs so far as I can see, so far as I've found. I think I need to go to sleep. I've lectured in about 8 hours. Dude, get some sleep. I mean, I realize the lecture is probably remote, but, you know, be sure you're there and attentive and all that kind of stuff. I'll see you around. Have a wonderful evening. Again, starting Wednesday, I'm going to be streaming a little bit earlier to try to catch the European crowds as well. Do you have a job lined up, or how do you know you'll be in Boston for the next 9 months? I can't really leave my apartment because my housing contract ends in 9 months. And also, I can't exactly leave my roommate just because, you know, we're friends and stuff like that. And there are extra reasons as to why I can't really just leave this place right now. So I'll just be here for the next 9 months, and that's how it is. Also, Boston housing really sucks. Like, it's just awful. It's just the worst. As far as being stuck in the US, I don't really know where I'm going to go from here. Like, maybe I'll be going to... There's potential that I end up in Europe. There's also potential that we... I don't know. I don't really know where I'm going to go from here. I have absolutely no idea. But whatever. Dr. Schleim's Joss to Europe when? I don't know. Do you accept guests? Guests? What do you mean guests? Like, at my apartment in Boston? Not usually, no. Okay, so what was I going to say? So we've got a couple things that I'm working on at the same time. Obviously, as far as videos are concerned, there is the next video that we're doing, which is going to be on the fractal flame method. Again, becoming a fractal, F-flamify. That's going to be the next video that we have out. But the video after that is actually going to be based on quiltify, which is the ability to turn any image into a quilt that we can then sew. I just basically need to create an image that actually looks good and see what we can do from there. So it might be kind of more of an artsy thing. Another thing that I wanted to work on is an AI swim coach. And so these, I think, are the next 3 videos, if I remember correctly, that I wanted to work on. So this one should be out sometime in January. I think this one's going to be in March. And this is going to be whenever I can actually do it. So the thing is, if I'm going to make the AI swim coach, I need to first write the code for the AI. And then I have to go from there. So I want to actually have the coach for a month so that it can, like, there's like some before and after, like, times and stuff that I could do. So I'm deciding, let's see, there's other things that I also have planned. Hear me out here. Just hear me out. Math fan fiction. Just hear me out. Is also on the list of things that I kind of want to do, and there's a very clear reason for that. Let me go ahead and catch up on chat here. Do you accept guests? I could see you in Washington. I mean, like, ASEC program. So, I have this idea of a book that I want to release on April 1st, 2021. The thing is, I can tell you guys on Twitch because a very small group of people watch Twitch, right? Like, for my channel. Most people watch me on YouTube, right? So April 1st, 2021, I wanted to put out a video that was called Gaussian Elimination. So, oh man, it's the dumbest idea. But the idea was that basically, you know, Frederick Gauss is going to collect all the greatest minds in mathematics and create torture devices for them based on like what they did. So for example, wait, what's the guy's name with the cage? Oh no, what am I thinking about? Well, obviously Maxwell has demons, Laplace has demons, Faraday has a cage, all this kind of stuff. Yeah, Faraday's cage. You know, they all have to like face their demons or face like, you know, something that's based. No, wait, I don't appreciate this. Wait, what do you mean? That's fair. Maybe it's a bad idea. But like, it's supposed to just be like bad mathematical fan fiction. And the idea is just, it's like released on April 1st, 2021. Don't harm mathematicians. That was kind of, I don't know. I don't know if we're going to harm them or not. I haven't really like written anything yet, but the tagline, okay. So I have to write this out because I don't know if I can actually say it with a straight face. So let me open up a LibreOffice or something. So the tagline is the following that I've written so far. So I've only written this. This is all I have so far. It says, they say that all progress is made by standing on the shoulders of giants. But one giant stands taller than the rest, and he's out for vengeance. In this novel. Watch Gauss do. what he does best. Eliminate. That's what I have right now. That's all I have of the book. And I was like, let's do it. Because it's just like, it's just the dumbest thing I could possibly think of. Remember to do Fourier transforms? Like Fourier actually isn't trapped at all in frequency space. It's just a bunch of fours. He's just trapped by fours because Gauss didn't. No, Gauss understands the Fourier transform. He was the first one to create the fast Fourier, the Cooley-Tukey method. So obviously he knows about Fourier transforms. But that'd be pretty funny if it was just a bunch of fours. Anyway, so that was the tagline of the book. For some reason, I can't get it out of my head, and I'm like, this would be the best book ever. And like, I know no one would buy it, but like, it's on my mind. It's like, I have to do it. But anyway, I don't know if I'm actually going to do it or not. If you guys, it's one of those things, like, if you guys think it's a good idea, I'll do it, but I'm not sure if it's actually a good idea or not. So Simuleos explains Fourier transforms. Let me make this bigger. I don't know, 20, something like that. So that was the plan. I wasn't sure if I wanted to do that or not. Speaking of which, we do need to redo the Fourier transform videos and all that kind of stuff. That's on the list of things to do. In fact, I'm going to be talking to someone tomorrow about that as well. So okay, just hear me out. Is this good or bad? Like, it's one of those things that I know is bad, but is so bad it might be good. And that's what I'm hoping for. I want it to be so bad that people are like, that's actually kind of good, you know? So most people are like, this is okay? Okay, so maybe on Writing Wednesdays, might do a bit of bad math fan fiction on Writing Wednesdays. That might be what we do for Writing Wednesdays from now on, until this is out. And obviously this is available April 1st, 2021. That's the goal. Like, it has to be on April Fool's Day. If it's not on April Fool's Day, it's just not going to work out. It has to be on April Fool's Day. Okay. It would become a meme that bad? Maybe. Anyway, that would be it. We'll see if I do it or not. I'll think about it. Okay. So these are kind of like the videos I have planned for the next few months. There's some other videos in the far-ish future that we have planned. But I don't really have any plan to, let's see. Oh, when you're making the Laos OS calculator with your voice clips for every button press, that is going to be April 2022. That is still on the plan. Like, I'm still planning to do that, but I haven't done it yet. So for those of you guys who are out of the loop, one of my favorite YouTube comments I've ever gotten was from some random person on my 4D video that said the following: if a calculator had a voice, it would sound like you. And I was like, that is brilliant. I have to turn that into an object. And so I wanted to build a calculator that, like, every time you pressed a button, it just has me saying, like, that option. So for example, if you press 1, I'll say 1. If you say square root, I'll be like square root. And like, it has to be like really slow. So if you like type things in, like, there has to be some stupid functionality that makes it completely useless, but very interested in doing that. I also thought maybe I could make it sellable. Why does Gauss eliminate anything? Doesn't the Gauss distribution contain everything from a group? That's all I know about Gauss. Well, no, so Gaussian elimination is a very common, so Gauss is known for like 10 different things. There's Gaussian elimination, which is a method for matrix operations. There is Gauss's law. There is the Cooley-Tukey method, which he came up with first. There's obviously the Gaussian distribution. And that's why Gauss is the best, like, right, Gaussian blur as well. Yeah, I mean, the guy's amazing. Like, he has so many things. Let's just go here. Oh, hello. Let's go here, paste. Which is why he's a perfect antagonist, because he's done something like in every field of research. Like, look at all, he has a Wikipedia list of things named after Carl Friedrich Gauss. Like, the guy's just, he has way too much. So that's why he's a perfect, perfect mathematical antagonist, because he can keep up with all the mathematicians. So, also, look at that smirk. I mean, for Pete's sake. I mean, he's just like, he knows he's smarter than you. Like, it's one of the few times when you look at a picture, it's like, yeah, that makes sense. You know? Anyway. Man, it's just, I wish I was that smart. No, he's not smart enough. He didn't use Arch Linux. Imagine him having a real computer. Man, if he had a real computer, like, I don't know, he'd be well beyond any of our comprehension. Okay, so let's talk about things that we need to do. So for flamify, okay, so let's just kind of knock this out one step at a time. For flamify, the next thing we have to do with this guy is go back to our fractal flame images and parallelize them so that they work much faster, right? So for quiltify, we actually have to make our first quilt. So the idea here is we just need to, like, basically what I'm going to try to do is make the stencil for the quilt. That's what I need to get done. For the AI swim coach, we're actually at our infancy in this project. We have to basically create the language specification for swimming. And then we have to think about how we're going to turn that into something that AI can deal with. And for the math fan fiction, I basically have to look up a bunch of mathematicians and try to figure out ways in which we could trap them in their own mathematical, ideas, right? So between these guys, let me just go ahead and create a quick straw poll here. Let me see what you guys are interested in. Straw poll. Why is that the first thing that you'd expect straw poll to be the first link when you search for straw poll? All right, create a poll. Hello there. What are we doing with our lives? Question mark. Okay. So one would be fractal flames. Next would be quilts. The next would be what? Oh, yeah, AI swim coach. And the last one would be math fanfic. Which we will actually do if that's what you guys want to do. So let's see what we got here. Allow multiple choices. Sure. Create poll. Yank. Over here. Paste. Oh, hello. Yank. Oh. Share maybe? How do I... Oh, copy link? I guess that's what I want. Paste over here. Okay, you guys should be able to look at that now and vote. Let's go here. Paste that there. Okay, you guys can... Oh, no, I misspelled... Oh, you kidding me? I misspelled R. I wrote out. Oh, that's so embarrassing. Can I change that? Pull edit title. Okay, man, that's super embarrassing. Oh, wait, it's not letting me... Oh, wait, no, it will. I'm just dumb. Our lives. Fractal Flames Quilt, Swim Coach, Math... Okay, save changes. Okay, while you guys are voting, I will be right back. Just because I'm going to grab some water, and then we can start the next session. So give me just a second. I'll be back in, like, a minute, and then we can go from there. So you guys vote. I'll be back in a second. Okay. Yep. So see you guys in just a minute. Okay, I'm back. Give me just a second. And then I'll show my face again. So you guys should be able to see me. I couldn't decide, so I voted for all of them. Me too. Just, no, if we have all of them voted for, then I'm going to have to be the tiebreaker, and that was why I was hoping you guys would... It's okay, we'll see what happens. Also, Murzu9, thank you so much for following, really appreciate it. Okay, let's see what the results are right now. So results are AI Swim Coach, right, okay, with 6 votes, whereas everything else gets 5 votes, and obviously Math Fan Fiction is at the bottom with 4 votes. That's okay, we can do that on Writing Wednesday. Okay, so AI Swim Coach, let's go. This is gonna be kind of weird. So let me go and change the stream title, and then we can go from there. AI Swim Coach. Sure, should be fine. Okay, AI Swim Coach, let's go. Let me get some water. Okay, so let's do it. I should be able to open up Zernal PP now. So you guys have selected the AI Swim Coach. Oh, I love this one so much. Okay, so let's talk about it. So, who here knows how to swim? Raise your hand if you do. I should have like a raise your hand emote, shouldn't I? Because at this point, you know, like... so T.S. Joss knows how to swim. Good, that's exactly one person who knows how to swim. So I do not. Okay, so in typical swimming, so this is specifically for competition. So let's talk about what the AI Swim Coach can and cannot do. And again, so right now we're at our infancy for the AI Swim Coach. We're literally just trying to figure out how this would work. There are people who can't swim. There are definitely people who can't swim. I used to be a swim instructor. I would teach people how to swim. So yeah, Linux, that's fair. Okay, fair enough. Okay, so let's talk about swimming really quick. Swimming. There are generally 4 strokes that we have to consider for swimming. There's butterfly. Oh, hello. Butterfly. Backstroke. Then we have breaststroke. Breaststroke. And then finally freestyle. Which typically is, it's not freestyle, it's typically the American crawl. And that's what I'm going to call it, American crawl. Now, the thing is, in principle, for anyone who actually swims, you'll know that this is always called freestyle, right? Always called freestyle. Freestyle. But actually, freestyle will let you swim any of these 4 strokes. It's just that the American crawl is the fastest, so everyone actually just assumes that freestyle is the American crawl. So it's kind of one of those weird things. So what does an AI Swim Coach do? Okay, so this is where it's probably going to be a bit... You guys are probably going to look at this and be like, oh, this is nowhere near. This is nowhere near as cool as I thought it was going to be. But the AI Swim Coach will not actually teach you how to do butterfly, backstroke, breaststroke, or freestyle. What it will do is it will take someone who already knows how to swim these strokes and turn them into a competitor in that stroke, right? So if someone says, I want to become really good at butterfly, they can select out butterfly, and the AI Swim Coach will give them a routine that will make them better at butterfly. That's the goal. Let's see. It's 1 a.m. over here, so I have to go to sleep. I guess a lot of US viewers should be coming from work by now. Yeah, thank you so much for coming in. Have a wonderful evening, and hopefully I will see you tomorrow. Again, starting Wednesday, I'm hoping to stream a bit earlier so we can catch more of the European audience. And we'll see how it goes. Show us how to swim. Good night, Radu. Have a great stream. See you later. Can you swim in a way that's none of these 4 in freestyle? I think you have to choose between the 4. It has to be a legal stroke. Speaking of swimming... so you guys know how the pools have all been closed for like, I don't know, maybe the entirety of 2020, and it's very difficult to find a pool. Well, really excited for this. I am the proud owner of a kickboard. Now here's the thing. I've been swimming all my life. I've used kickboards literally all my life. But I've never owned a kickboard because usually the kickboards are available from the pool. Like you go to the pool and the kickboard is there, sitting at the side of the wall. But no, I've bought a kickboard, and I'm super excited for this. When I get back in the pool, I'm gonna be pretty slow because I haven't swam in a while. But I'm really looking forward to it, and I really wanted to make it so the moment I jump back in the water, I'm gonna like time myself and see how crappy I've gotten, and then I wanted to use the AI Swim Coach to really just like improve myself over the next month, and I wanted kind of like a before and after the month of training, where like, you know, we'll do the typical like, here's, you know, shot of my body before and after, which is probably going to look the same, and then, you know, times before and after and all this kind of stuff, as kind of like an advertisement to say, oh, the AI swim coach works, even if it doesn't really. I don't know why I'm so excited about this, but I'm just really excited. Okay, so how does this work? Has a pool? I wish I had a pool at home, honestly. One of those endless pools. The endless pools are really cool, and I've always wanted one. So for those of you guys who don't know, an endless pool is it's one of these pools that constantly pushes water at you. So it constantly pushes water at you, so that you can keep swimming without a break. Do you train the eye? So so this is the thing. The AI will be trained based on my training, right? So what I'm thinking about doing here is using a form of reinforcement learning, which we can do. So there should be, let's see. We want a form of reinforcement learning that allows for, so we have the interpreter, and essentially what we'll do is we'll time ourselves at the end of every week. And the idea is after timing ourselves at the end of every week, we should then provide feedback back to the agent, who will then, or the interpreter. Actually, I need to think about this. It will be, is it supervised or unsupervised? Sleepion, thank you so much for following. Really appreciate it. Actually, that's a good question. I suppose it's going to be, I have completely forgotten. This is me being dumb. Supervised reinforcement learning. So supervised learning is the one. Oh, let me just go back a few. Back one more. Supervised. Okay, so reinforcement learning differs from supervised learning in not needing labeled input-output pairs to be presented. Okay, so reinforcement learning is one of the three basic machine learning paradigms, alongside supervised learning and unsupervised learning. Right. So anyway, we'll see what happens. I think we can use this, but I think today we're actually going to focus more on language specification, and this is where things get a little bit tricky. And I just need to explain something to you. I may or may not have created a programming language for swimming. Now, when I say may or may not, I mean that I have created a programming language for swimming. So let me go to github.com. And what I'm going to try to do here is I'm going to go to my swim repository. Swim. Here it is. And I'm going to try to kind of explain it and figure out what we need to do. So let's go over here. We're going to, I don't need all these terminals up, right? CD. Okay, so now this image up here doesn't work anymore. Should I just get like an image of me swimming? I don't have an image of me swimming. Could I just play like a YouTube video? Is there like a YouTube video of people swimming that I could just play up there in the corner? Let me see if I can get that so we have some visualization on screen. Actually, let's get CD projects, get clone. There we go. What language is this in? Well, right now, so what we're going to do is we're probably going to use Julia to metaprogram our swimming programming language. So Swim is a programming language. I'm going to explain it in just a second. Let me see if there are any Creative Commons swimming videos. Let's see what we got. Videos. Competition. I'm just gonna really quick. I don't really see anything here. So let me try doing this on Google. Videos. Tools. Any duration. Isn't there a... There should be a... Wait a minute. Okay, never mind. We're just not going to have a visual up there in the corner. We're just going to change this, and it's just going to be a large terminal that says huge. There we go. Clear. That's all it's going to do. Means swim will be an exotic language which will be used to create an AI. No, that's not what I mean at all. Just hear me out here. So we're going to go here, seeding to swim. That's not what I meant. Okay, L is here. Seeding to sets. L is here. And let me go into vi medley.swim. Okay. I want an infinity edge pool. Honestly, like, I think that'd be pretty cool. Is there a terminal? Oh, how about we do Ask Aquarium? In the corner here. Perfect. There we go. That's exactly what I wanted. We can make this even large and move this over here or something. There we go. That's kind of vaguely swimming related that I think people would appreciate. Okay. So a long time ago, when I was back in Okinawa, I was trying to think of a way to express the workout that we were doing in a way that would scale in difficulty, right? So that I could do difficulty 7, I believe is what I was doing, or difficulty, yeah, I think difficulty 7 was as far as I got here, which was 6,500 meters. What was it? It was in maybe an hour and a half, 2 hours, something like that. I think it was an hour and 40 minutes is what I did it in. But it could go up to 10K essentially, as far as this particular workout is concerned. The idea was that essentially we have a bunch of builds, bookends, IMs, all these kind of different sets that we would have that would allow for me to train certain strokes. So what I need to figure out now is what control we're going to give the AI. So this particular set was created specifically for singling out the individual medley. That is to say, butterfly, backstroke, breaststroke, and freestyle I'll put next to each other. So the idea with this workout was that we start with a 500 warm-up easy, and then we iterate through all the different build sets that we have. And depending on what build you have to do, or how many build iterations you have, this will be harder or easier, and that also changes your interval, right? So here we swim freestyle for 100, and here we swim IM of J for 100. So in principle, I could make this a bit easier. Like this could be simpler if I just say swim IM colon or something like that. The syntax isn't great, but essentially for all 4 strokes, we're going to swim through. We're going to do 100 build for each of them, and then we do 100 freestyle at medium pace, right? That's how you'd read that one. So now bookends are kind of interesting. The idea is that we do like 100 or 50 in the middle. That's hard. And then 25s on either end that are something else. Maybe not hard, could be easy, I don't know. So the idea here is that we're going to do IM of the previous stroke. So it goes butterfly, backstroke, breaststroke, and freestyle. So the previous stroke is going to be freestyle, butterfly, backstroke, breaststroke. So you kind of go the stroke before it. And you do 25 easy of that stroke, then 50 of the hard stroke, then 25 easy of the stroke before it again. So that's kind of the idea with this guy. And again, you just swim easy. This should be hard. That's embarrassing. And then now here we have the IM set, which is basically going to say, we do a 50 strong kick, and then we do 200 strong IM. And that's kind of how it works. And so the idea is you kind of go through these different iterations as you need. In principle, I should have had a 400 IM set as well if I was training distance IM, but I wasn't at that point. So this is just a very basic medley workout. So what I'm going to try to do now is I'm going to try to enumerate. So first of all, the big question that we have here is, what does the coach actually do? All right, so what does the coach have control over? Obviously, it has control over the difficulty setting, right? Right, so the idea is that we want to create an extensible language that allows for us to express languages or express these workouts in a way that we can change the difficulty on the fly and have something that's remarkably difficult for advanced swimmers, but also easy enough for people who are just getting in the water for the first time after a long break. So that's one thing that it needs to be able to control. Now, the next thing is, what exactly in the workout does it control? Does it control, like, let's say you're trying to tone a particular muscle group, right? Like, let's say you're trying to make butterfly. You're trying to make it so you're better at butterfly, right? Well, then in that case, it probably needs to also increase, like, probably the amount of a particular stroke. So stroke, like, not stroke amount, like how much you swim the stroke. So stroke, what am I looking for here? What is a word that means the amount of something that I can use in this way? So like, if you want to say, I guess we'll just say stroke amount, sure. Okay, and so after that, we're going to do, what else can it control? Probably the type of workout, so type of event, of swim. And most importantly, it controls the intervals. Now, this is what the swim workout language that I have right now does not do, and it should. It should control the intervals, and I don't have it controlling the intervals, because it doesn't really matter how long you swim. It matters if that swimming is actually effective, right? That's what actually matters, you know? I want infinity be equivalent to. Yeah, I guess. So, so I need to do a few things. So let's just kind of enumerate the things that we need to do. So the first is, we need to, make the swim language, we'll say more expressive. More expressive. That's one thing we need to do. So the next thing that we need to do is we then need to, obviously, we need to find some sort of AI that can then write the code there. And then 3, we need to actually like do the workouts. So big questions I have here. Right. Does the AI control, for example, dry land exercises? Does it or does it not? I don't know. Should it? It needs to tell you the history of each stroke when you first select the stroke. The history of each stroke. What do you mean by that? And so for the record, guys, we are at, just to make sure everyone's on the same page, we are at this stage here where we're trying to figure out what this language is for the workouts that we're going to be using for the AI to meta program. That's where we're at. That made me think of sports research. Are there any studies about swimming effectively and efficiently to determine the intervals? That's probably a very good stroke repetitions, reps. Yeah, probably, yeah, stroke amount. How about stroke distance is probably what I want. Stroke distance. Distance. Because usually you don't think of like how many butterfly pulls you're going to do. Okay. So since we're at this first stage here, and actually, Martin, I think you're right. There are probably a bunch of good, let's do sports, oh gosh, coaching resources, I suppose was one. Coaching, swim coaching resources for optimizing stroke efficiency. No way this is going to couple with anything. Swim faster, perfect stroke technique. Yeah, this is, we're beyond that. Stroke count and stroke drills. I mean, we might just start reading stuff about swimming. Also, do you guys think this belongs in science and tech, or does this belong in just chatting? Because we're going to do a lot of talk about swimming, which is not exactly science related, but it will eventually turn into an AI swim coach. So is this, what do you guys think? Should we maybe switch to just chatting, or is this scientific enough that you guys are happy to be on science and tech? Keep in science and tech? Okay. Because we're probably going to talk a lot about sports theory in some sense, which I don't know if that counts as science and tech content, you know? I guess science. Okay. Publications. Ooh. Ooh-hoo. Anytime you see publications, I'm interested. Okay, so competitive swimming blog. What is this? What is this article? Stroke count and stroke rate. In this article, we'll provide examples of stroke count and stroke rate drills that can improve swimmers' technique. Okay, this is fair. And that's what I meant over here. So when we say type of swim, this also means drill. So whether we're going like, so this is hard, medium, easy, but also the way in which you're swimming, which could be like different drills and stuff that you need. So, okay, let's look up a few more things, see if we can find anything online. I might even just Google AI swim coach, see what we can do. I really haven't looked into this at all, so like we're really just starting fresh here. And if we can't really find anything, I'm going to just go. We're going to try to figure out what we can do. So I'm just going to start to write things down, and you guys are going to tell me if this feels wrong, or if it feels like we can't really use AI for this, or anything like that. Like, you know, you guys are going to be the little, you know, folks on my shoulder telling me that this is a dumb idea. Okay. So obviously there's different drills that we can do. Let me try Googling this instead of DDGing it. So this should work. Stroke count, stroke rate drill, same thing. Eat, swim, coach. Eat, sleep, swim, coach. Heh. I do feel like this is a good learning website though. Like, it says publications on it. Like, it has to be good. Swimming quizzes? Hey, do you want to do a swimming quiz? What is this? Welcome to our swimming quizzes. Free, fun, educational, brain-teasing games, word search puzzles, multiple choice quizzes. Get the picture quizzes? Word search puzzles. How do we... Where are the quizzes? I can't click on anything here. London Roar World Search Puzzle. No, we don't want to do these. I was hoping to like have a, what muscle group do you work when you're doing butterfly type of thing. Never mind. That wasn't what I was hoping for. Engage technical training for swimming. Maybe this is what we're looking for. Content.short. Let's see what we have. Thanks for that, by the way. Paste this in here. Okay. Muscle power predicts freestyle swimming performance. Oh, right. Yeah, that's fair. But the question is, which specific muscle groups do we need? If you wish to reuse any or all of this article, please use the link below, which will take you to the Copyright Clearance Center's rights link. You'll be able to get a quick price and instant permission to use. What is this published in? Sports medicine? Do I have access to that? Probably not. What if I just click this PDF button? Did I legally or illegally download this? I'm gonna guess legally. We'll pretend it was. That has to be legal, right? Like there was a PDF button on the site. Yeah, it has to be fine. Okay, so let's open this up in Zernal. And actually, let's move it. So we're gonna CD into projects, project swim. L is here. I think we should just read through it. Like, just kind of, not read through it, but just kind of browse it, see what it's saying and stuff like that, so we can figure out where we want to go. So let's just go ahead and make directory on notes, CD into notes, and then CP downloads. What was it? 151.full.pdf here. Perfect. Twitch rules, I see. Yeah, so I think it should. What's the licensing for that? The licensing here, does it give licensing? Article information. Citation, publication history, request permissions. Copyright. It is copyrighted. I feel like maybe I shouldn't. It is copyrighted. I probably should not open that up on stream. That is a long URL. Open this up. Sure. Is this the same PDF? Or is it different? Effects of repeated days of intensified training on muscle glycogen and swimming performance. This is, yeah, okay, this is super useful. We should definitely talk about this as well. Different study. Yeah, this is great. Thank you. So we're going to CD into project swim notes. We're going to move downloads. 1 second. Effective here. Okay. So I have those ready to read. I'm probably going to read them off of stream because I am afraid about licensing issues. And I mean, I realize I'm already not, the fact that I already opened up that article probably means I'm not doing very well. How do I, just click on it. Perfect. Oh, no. That wasn't what I meant to do at all. Okay. Right. So what I'm going to do actually is take a step back and I'm going to still kind of enumerate things that I feel like kind of talk through what I feel like this AI swim coach should and should not be able to do. Again, one thing that it can't do is fix someone's technique, right? So if your butterfly sucks, this AI swim coach will not be able to fix your butterfly technique. What it should be able to do is build particular muscle groups that allow for your butterfly to be faster, right? So what does that mean? Let's hone in specifically on butterfly as an example. And again, I'm just kind of thinking this through. If you guys think I'm doing something wrong, let me know. Martine, yeah, feel free to keep sending me links. Those are super useful. Probably going to go through those off the stream to think about them. And let's go. So let's, again, think about specifically butterfly. Okay, so butterfly. Let's see what this one is. Okay, open up over here. Paste there. This one is, sure. 119.pdf. Okay, CD projects, swim. LS here, CD notes. LS, move. 119. Downloads. 119.pdf here. Ocular 119.pdf. This is myography and swimming, a systematic review. What does this mean? Oh, it's just the that one's not even the whole article. That's okay. Here, paste there. And this one is fine wire and electromyography analysis of muscles of shoulder during swimming. Right. Okay. This is super useful. Cool. Cool. Phoenix Fukari, thank you so much for following. Really appreciate it. About muscles. Yeah. Okay. So let's talk about butterfly then. So let me just show you butterfly, just because some people might not know what butterfly is. So let's do butterfly swimming. And surely there has to be some videos I can show, right? Videos, settings. Can I do... Maybe I need to do this specifically in Google. And let's do more. And there should be licensing. Tools, all results, verbatim. Surely there's licensing, right? All videos, any source. No, I want... inequality. I know if I do images, I can do tools, usage rights. Huh. Do you think the resume or the GitHub profile is more important to getting a job? I probably resume. I would argue it has to be resume, right? Because some people are not able to put their GitHub, they're not able to put their code up on GitHub to begin with. So if it's not the resume, then you're really gimping some people. On the other hand, I mean, having a good GitHub repository or a GitHub page, I think really does help in some ways. So, it kind of depends. Definitely what you're looking for. Over here, paste. What is this one? The normal shoulder during butterfly swim stroke, an electromyographic and cinematographic analysis of 12 muscles. Interesting. All right, let's bring these over here so I don't accidentally delete them, because I will use them later. I just need to figure out what I want to do with them. Reinforcement learning. Okay. So let me just... Okay, let's just do Creative Commons licenses. This doesn't help at all. Okay, what if I just watch a video from YouTube? Is that bad? Can I watch videos on YouTube on Twitch? Watching YouTube videos. Is that allowed? On Twitch. I think that's fine. Yeah, right? Should be okay. I think people do that all the time, right? Let's just go to youtube.com. And let's take a look at Michael Phelps swimming. Butterfly. I just want this. This is all I want. Nope. Oh, no, that's not what I just wanted a minute. Try that one again. Can I not go back? Okay, let's try this again. Michael Phelps, let's do 200 butterfly final. That should do it. Okay. I think so, yes. Only music could be problematic because of copyright issues. I feel like video should also be problematic for the same reasons. But okay, let's full screen this. Why not? And I'll just take a look at it and remove that ad. Okay, so this is Michael Phelps, swimming butterfly. Obviously getting on the block. Okay, and I think actually let's just look at this really quick. So the first bit, so if we're doing swimming training, right? The first bit is actually kind of difficult. Like, we're actually starting here. The moment that he jumps in the water, right? The start is actually something that we do need to train. Joey Bola, thank you so much for following. Only music could be problematic because of copyright issues. Okay, then let's not watch the video then. Let's, instead of not let's just kind of skip through it. I mean, I'm not really restreaming it, right? Like, it's one of those things that's probably almost certainly fair use, right? Like, I'm analyzing this. But at the same time, like, okay, so again, if we're going to do AI training, the first bit starts here at the start. Like, right when he jumps off the block. So right here, right? So like, as he jumps in, obviously you're engaging a lot of muscle groups, just in the legs and stuff like that. So that's something that we have to train regardless. And you train that via squats or some sort of dry land exercise, right? So you're in the water. And now we're talking specifically about butterfly here. And so, obviously, as you're bringing your arms across, you've got a lot of shoulders that you have to train for, but this is actually predominantly an abdominal stroke. So obviously you have to have strong abs, right? So the question is, how much of the training needs to be done in the water and how much of the training can be done on land, right? I mean, again, we're not playing any, like, we're not really restreaming this, so I think we're fine in terms of licensing is concerned. Right, so then he did 6 dolphin kicks off the wall, so there is some breath training that needs to be done in the water, but that doesn't really help too much. So then let's see. We're gonna let this guy keep going, but obviously, like, at this point, it's mainly shoulders and abs. That's kind of what we're focusing on right now. Shoulders, abs, and a little bit of calf workout. So what I think we want to do then is we want the AI swim coach to do the following, right? So we need to figure out a way to... So with butterfly, we know what we need to focus on is shoulders. We'll say frontal abs, as opposed to obliques. Because you do need obliques, but not as much as you would need in, for example, freestyle or backstroke, right? It's also going to require, obviously, for the start. So in general, it's also going to have to require, for starting and pushing off the wall, it's going to require the quadriceps, and then also, obviously, the calves, right? And actually, I might just put calves over here instead. Calves. Okay, so what else do we need here? And when I say shoulder, I mean like the whole area back there. I'm not very good with like the muscle groups and stuff like that. So let's remove this guy over here, and this guy up here. Okay, and now what we're gonna say is what can we do to work these out? So obviously, one thing that we can do to work out all the muscle groups that you need for butterfly is swim butterfly, and a lot of butterfly. But the disadvantage for swimming a lot of butterfly is that if you're swimming a lot of butterfly easy, then if you're swimming a lot of butterfly like really easy, that's not necessarily going to engage the correct muscle groups, because you kind of need to be swimming at race pace to really like get that crap down, like to really figure out exactly what you need to do. So we probably need some dry land exercises. So for shoulders, obviously there's shrugs, and jump roping. Oh, actually, yeah, there's shrugs. There, for frontal abs, there, I'm going to say crunches and bicycle crunches, for example. And then for calves, we have calf raises. Something that works out all of these guys would be jump roping, jumping rope. Right. For cardio, obviously, yeah, there is a lot of cardio in here as well. So, but I was going to put that down on the next thing. So we'll talk about cardio, here. So there's obviously running, swimming, and again, jumping rope. So, and obviously in terms of cardio, the best cardio exercise you can get is going to be swimming. You could argue that jumping rope, if you could consistently jump rope for like an hour, then jumping rope will burn more calories than swimming, but swimming burns more calories than running. And jumping rope is one of those things that you can't, just trust me on this one. You cannot jump rope. Like, I'm I would be very surprised if someone could jump rope without, like, just consistently for 20 minutes without stopping. It is hard. Like, it is really hard. You really got to push past, your limits on that one. Every morning I usually do about, I do 100 normal jumps, and then I do about 200 doubles, along with some other additional things on the jump rope. It's hard. It's not something that you're just going to be able to figure out. Or just be able to do. So I reckon that for cardio, you're probably getting most of the cardio you need from swimming. But you should also have the dry land exercises. So the question is, does our AI swim coach also allow for these dry land exercises? And I think the answer is probably yes, it probably should, right? Because, for example, if you're specifically trying to get better at butterfly, then you need to be able to work out specifically your shoulders, your abs, your calves, and stuff like that. Like, you're just going to have to need to do that. Now, here's where the learning comes in, and here's where the bit that I don't understand comes in. How does the AI know that you need to work on your shoulders or your abs, or how does it know? Like, obviously, if you're training butterfly, we can tell that these are the muscle groups that you need to focus on, let's say. But how does it know that, in particular, your shoulders are the weak part? Should we provide specific data for that? Like, what type of data would we have to provide for that? I suppose what we could provide is, we could just do as many shrugs as you can to exhaustion, as many crunches as you can to exhaustion, as many calf raises as you can to exhaustion, and say that this should be, naively, this should be at a certain stage, right? Like, you should be able to do, I don't know, like maybe 400 calf raises before crapping out. 400 is a lot, though. I mean, honestly, before having to stop, I could probably do about 100 before having to stop with calf raises. So 400 might be too many, but crunches, I can do like 1,000 of crunches without having to stop. Like, crunches are easy. In fact, that used to be my workout. I used to just do 1,000 crunches. That was what I did. And I just did that, like 1,000 bicycle crunches. That's what I did. Yeah, still fat, but that's what I did. Okay. So I think that's fair. Okay, so the next thing we need to do is journal a new page before. Now let's talk about drills. Okay, so in addition to having to work out these muscle groups, there's certain drills that you can do to make you better at butterfly. Like, for example, you could do, what? Let me see, Martin. Dumbbell weight pull capacity might be an indicator of how strong the shoulder muscles are. So, right, the issue with that is that, if you are like incredibly strong, like you can lift a lot of weight, that doesn't indicate that you can actually use that weight, use that muscle group extensively for a long period of time. It's a difference between like explosive short muscle fibers and kind of long body fibers usually used for like muscle fibers usually used for like endurance activities. So like doing squats at high weight is not necessarily indicative of you being able to run really fast, right? In fact, doing really high weighted squats is indicative of you not being able to run particularly fast. I mean, faster than the average Joe, but certainly not as fast as a marathoner or triathlete type of thing. Okay, so for drills, let me think. So we have like half stroke. We obviously have my favorite, which is a fist drill, which is just where you don't have your hands out, you have them in a fist the whole time. This helps you really try to hone in on getting the forearms a bit stronger. Then let's see, what else do you have? Yeah, I mean, other fun ones like 3 strokes per breath, for example, stuff like this. All of which work different things, right? Half stroke focuses on undulation. Fist drill focuses on forearm strength. Whoa, that's a word. Yeah, let's pretend you guys can read that, because you definitely can't. And this obviously focuses on breath control. Any resources for staying fit at home? Honestly, for staying fit at home, I literally just go for runs. It's hard because I used to do everything in the gym, right? So, I mean, don't get me wrong, like there's like Ring Fit Adventure is actually relatively good in terms of like just a home gym. Like the little, like fitness wheel thing or whatever it's called, it has some good resistance to it. So in terms of just like basic workouts, I would argue that, yeah, Ring Fit Adventure is, as far as a workout is concerned that you can do at home, relatively good. But I still think the best thing you can do is probably go for a run. So what I do is I do roughly a 5-kilometer run every day. I've been relaxing, but what I've been trying to do is a 5-kilometer run every day, interspersed with 100 or basically 20 doubles per kilometer. So the idea is I run 1 kilometer, and then I do 20 doubles on the jump rope. And then I run another kilometer and I do 20 more doubles on the jump rope. Now, if you recall from just a few minutes ago, I said I do basically 200 doubles, and you might notice that 200 times 5 is only 100. So where's the extra 100 doubles? That's because it has to be 200 consecutive doubles. And if I break, I have to do it again. And oftentimes I don't get 20 consecutively. So Alexi47, hey, how are you? Thanks so much for following. Hey guys, I hope everyone's having a great day. Yeah, I hope you're having a great day too. Thanks for coming in. Endurance is probably related with the production rate of lactic acid as well as sensitivity to it. Yeah, that's also true as well. Okay, so in this case, what we probably want is, so ideally, right, if this particular AI had an infinite amount of time to train and to learn, what works best? I think what we'd probably want to do is create an n-dimensional space, space, which is composed of all the different workout routines that we could do. Like for example, we have obviously the amount of time in the pool, which is composed of drills and different sets that we can do, all this kind of stuff. And then we have the dryland exercises, which is composed of different exercises we can do there, running, we'll say shrugs, whatever, this type of stuff. So the idea would be that we then allow this AI to traverse through this n-dimensional space. And every week we do a training recap where we basically say, have you gotten faster in this week? It has to be probably every month, honestly, and that's going to be pretty hard to do. So I have a feeling that we're going to have to do something. We need to give it some feedback every day after every workout, and I don't know what that would be. So what type of feedback can we give this? We can obviously give it like how sore your muscles are, what particular muscles are sore, and that type of stuff. So, we include a diet program. I should include a diet program, but I think the assumption would be that if you're at this stage of training, you can manage your own diet. Specifically, calorie intake. You might want calorie intake. That's fair. Maybe not so much you have to eat these foods, but how many calories are you eating might be useful. Yeah, that's true. Okay. So what else do we have here? Let me get some water. Okay. So what type of feedback can we provide this? Feedback. Okay, naively we can provide muscle soreness. Muscle soreness. Let's try that one again. Soreness. We can also provide, I guess, happiness. Like how good the workout was. Do you feel like you worked out? Do you feel like you were training? This type of stuff as well. Let's see, what else do we have here? What else can we provide this AI at the end of every workout? Now, obviously, at the end of every month, we can provide times, and in particular, the times that we care about. If you're focusing on butterfly, then you focus on, improving that butterfly time every month or something like that. So this is something that we can do every month. That seems fine. Okay, so now I think we have the ability. Yeah, okay. So now we just need kind of a list of everything that we could potentially do. And then after having a list of everything that we could do, we then just kind of let the AI pick workouts. And then I think what we'll do is we'll actually just kind of let the user indicate whether they feel this is a good workout or a bad workout, and whether they should scale that workout up or scale it down. I think that's what we should do. So I think for today, what I might do is I might try to create a new swim workout specifically with butterfly in mind instead of medley. So instead of butterfly, back, breast, and free, I focus specifically on butterfly, and I think about what I would want to do to create that workout. Because again, I used to do this a lot. So then after we create that, or after we do that, we should be able to, yeah, that should give us some ideas of kind of what we're looking for. And then maybe we also think about what we do for dry land as well. So let me just do write and quit here. Okay. And I'm actually just going to copy the medley.swim into a butterfly.swim and see what we got. I'm sorry, guys. This is kind of weird. So let's cp medley.swim into butterfly.swim. And let's just open up butterfly.swim. And let's think about what we'd want for a butterfly workout. I'm sorry, this is so weird. I know this is like a very weird thing to do. Yeah, let me know if you guys... Okay, also, let me know if you guys think this is interesting or not. Like, if you guys don't think it's cool to do an AI swim coach, I think it's cool to do an AI swim coach, but I think we're kind of in the... Because we're in the infant, like the starting stages here, and we don't really know what we want the AI to control, we're kind of at a stage where we don't really know what to do with it. And so I think that's kind of where we're at. We're trying to figure out how to parameterize this swim coach idea. So this is going to be for general purpose development of butterfly is what this is going to be for. Okay, of butterfly. I'm going to leave this up here. We're going to fix it later. Okay. So let's do it. So we're going to do set butterfly is what we're going to call it. Okay, for some reason I have it reading in a scale and a pool type with short course meters, even though I'm not using pool type at all, but I think that's totally fair. So we'll do scale, which is going to be how difficult you want it to be, and then also the pool type. Which is going to be equal to short course meters as well for now, just because that's what I'm used to right now. I'm going to just go ahead and just remove all of this. And we're just going to... Well, I shouldn't have done that. Because now I don't remember. Okay, let's just go over here really quick. Control D, CD, CD project swim. LS here, CD sets, LS, and let's go into VI medley.swim so we have it up here to kind of look at. Okay, so so when we think about workouts, what is the typical, like what would you typically do for a workout? Obviously you have warm up. So for the warm up, how did I do it before? I think it was just a static 500 warm up. So I think it was just warm up, which would just be swim. Usually it's freestyle. 500, easy, usually easy. Okay, and then for cooldown, usually I do like 250 cooldown, but I think down here I wrote 500. So yank to yank, and we'll paste down here for cooldown. And we'll do, again, 500 freestyle easy, should be easy enough. Okay, so if we're gonna do a butterfly workout, the problem with butterfly is it's a very, like intensive stroke, right? Like you usually doing butterfly for a long distance isn't going to help so much because, I mean, I think, the most you're going to swim in butterfly, I think there is a 400 butterfly. Is there a 400 butterfly event? Is that what he's swimming here? 200 butterfly. I think the longest event is 200 butterfly. Olympic swimming events. Sure. Okay, Olympic team trials, day one swimming packet. Wasn't what I was looking for at all. That also wasn't what I was looking for. Crap. 7. Let's do swimming at the Summer Olympics. Seems fine. Okay, so it looks like we have 400 meters freestyle, but it looks like for butterfly, breaststroke, and backstroke, the highest is just 200 meters. I just won a game of chess. Congratulations. You're talking about chess and we're over here being jocks. So, cool. Okay, great. Also, they just added an 800 meter freestyle, which is really cool for men. So there used to be an 800 meter freestyle for women, but not for men. And there used to be a 1650 freestyle for men, but not for women. But now women are able to do 1500 freestyle. Sorry, 1500, not 1650. And men are able to do 800 freestyle, which is kind of cool. I didn't make any embarrassing blunders. Oh, that was the other thing. So again, I've been thinking about doing non-programming content a lot on stream recently. If there's something that you want to see, feel free to let me know. In particular, I've been thinking about like different, challenges that we could do. Obviously there's creative writing, but I have been thinking about playing Guild Wars and doing particular challenges with Guild Wars. I thought about doing a Guild Wars skill Nuzlocke challenge, which seems kind of fun, but also like, I don't think anyone here in this stream watching right now would know what that means. But I just thought it'd be kind of cool maybe to do a challenge run, but I don't think people here would be interested in that. Like, I don't know. We'd see. Okay. So it only goes up to 200. I'm thinking about chess, specifically Leela chess engine. Leela chess engine. Leela chess engine. So if I'm being honest, I'm just not, I'm not super into chess. Maybe I should be, but I'm just not. It's open, and each time someone plays against Leela, it continues training. We could try. I mean, why not? I could try playing chess against Leela. I just have a feeling like I'd screw it up because my chess is so bad. But yeah, so as far as, I don't know. People have suggested that I should play chess, but I don't know if I want to do that. So we'll see. Is it possible to make your AI coach open and train itself with each user? Yeah, we could do that. If we wanted to make it so there were multiple people doing swim workouts, this would be good. The issue with that is, that is a good question, and I don't know the answer to that. If we can scale the swim coach based on difficulty, then we could just make it so I would do the same workouts as everyone. So I'm gonna be honest, I'm a bit like my swimming is pretty good. Like I was the fastest swimmer at OIST. By a wide margin. Like I was by far the fastest swimmer. I have 750 elo. I don't know what that means. I didn't even know you could have elo on chess with chess. But I guess you can't. I don't know. But yeah, as far as the AI swim coach is concerned, like having multiple people do it would allow for more data. So what I might do is I might actually, hear me out here. I might do an AI swim coach video where I say, here's my AI swim coach. If you're interested in doing this, please download this app. And if you download the app, then you can also do training and then it will learn and become a better coach. Like we could do that. It means that I'm not great, but not completely trash. See, the thing is I'm probably completely trash because I haven't played chess in a super long time. So I'm almost certainly trash at chess. Okay. So... Okay, when we think about workouts, and we think about, see, like, here's what I'm saying. Like, for example, a 500 warm-up would actually probably be a bit difficult for people who don't have, like, significant swimming background. Also, become personalized as well as based on the feedback. Right, that's true as well. Okay, so let's just create this butterfly warm-up, or butterfly workout, and see what we have to do here. So... I would argue the butterfly workout needs to train your butterfly speed more than it has to train anything else, right? So let me think here. So, my fear also with doing an AI swim coach is that people will, so swimming, the most important thing about swimming is not the yardage or the distance. The most important thing is the swimming technique. And if you don't have the technique down, then no matter what AI swim coach we give you, it's just not going to be good. You really need to get that technique down first. Otherwise, you're going to have you could have massive issues with your shoulder or so many other things, right? So like really and truly, the first thing you need to do is get that technique down before focusing on anything else. And this is beyond that stage. This is after that stage where you already have your technique sufficiently nailed down. Okay. So what would we do here? So in principle, there's a bunch of things that we could do here. We could do builds. We could do bookends again. We can do kick sets. What else do we have here? We could do, this is specifically for butterfly. So we don't really need to focus so much on turns because turns are relatively straightforward for butterfly. It's just tap and go. But what we might want to do is pull sets, which will help specifically with shoulders and stuff like that, which you need a lot of shoulder training for butterfly. Another thing that might be useful to think about, although this would be this would not be the typical workout for butterfly. Another thing you could probably think about would be treading water, or like exercises that are specific to butterfly itself. So like core kicks, for example, which is where you hold your body at a 90-degree angle, and you do butterfly kick or dolphin kick. And this will actually, it will really help your abs develop, because it's like very strong on the core. And the core is obviously the most important part to butterfly. Another thing that we can do is treading water, water with butterfly kick. Okay, and the last thing we probably want to do is actually train a bit of breaststroke. As well. And the reason you want to train some breaststroke is because breaststroke is also another short axis stroke. So breaststroke and butterfly are almost identical in stroke, like in the way your body undulates through the water. They have almost the same pulse. So like if you're training freestyle, you also want to train some backstroke. If you're training butterfly, you also want to train some breaststroke. In my opinion, I think this helps a lot. Now, the trick here is making sure your knees don't start hurting because of breaststroke and stuff like that. But usually you're fine as long as your technique is okay. What else could we do for butterfly? Let's see. I'm gonna capitalize that. Now, usually for IM, you could switch between different strokes as well. And I might encourage doing, so there's also breathing, so underwaters as well. Underwaters, right. And then again, butterfly is such an explosive stroke. I would consider doing drag training as well. All right, what else could we do here? See, I think the problem with this is chat doesn't know what I'm talking about. Like, I think we've gotten to that point where like I'm just talking and like no one is following what I'm saying, because like, okay, I know when this happens a lot in chat, because chat gets really quiet and no one says anything because they're all just kind of like trying to figure out what I'm doing. And I feel like we got to that stage in stream, so that's good. I guess I've been lost for the past hour. Sorry about that. I'm vibing. That's cool. Yeah, Linux, you said you don't even know how to swim, so vibing in chess, that's fine as well. Okay, so that means we have all these different things that we could do. So what are each of these guys? So builds are where you start off slow and you get faster. The nice thing about builds is that they train specifically. Yeah, Martine's still here. That's fine. We have at least one person. So builds train race pace a bit. Because you start slow and you get faster. That's the other thing. You probably also want some actual, no, you don't want to do races on the same day. So let's go here and let's do race pace. Sets. All right, that'll do. Okay, so this is kind of like, and also drills. So the big issue with drills is that a lot of people will, when you do a particular drill, a lot of people will like go easy during the drill. And so for that reason, I typically don't like to say like, I don't know, like if you think about the drills that are good for butterfly, right? Like I said, you've got like half stroke. There are things that are slower. And so the last thing we do need to consider here are the intervals for which you'll be swimming. So interval for swimming. So back when I was in Okinawa, I would always swim with my workout partners. And my workout partner was relatively good at swimming, but somehow, he like, I don't know what it was, but he kind of staked, he kind of like put his entire like self-worth based on his swimming ability. He was a PhD student and he didn't swim as fast as I could, but something about the way in which he swam, he was like, yeah, like, I don't care if I'm doing well in my PhD or not. All I care about is if my butterfly is, under 30 seconds for a 50, like something like this, something basic, and there was just something about it. Like, he just got terrified anytime we did interval training because he realized, like his swimming wasn't as fast as it could be and all this kind of stuff. So he hated interval training so much. But I I love interval training. It's so much fun. I'm following, don't worry, I'm following. You took the AI and asked the swim coach to put on the side stroke and not when the water was taken. It was breaststroke and the core kicks. There you go. You're following pretty well. But yeah. Okay, so if I were to create a workout for butterfly, I would take a subset of these events, and I would think about how we want to link them all together. Let me take a look at this as well. Open that up, paste this down here. Where we have influence of different rest intervals during active. This is also useful. Thank you. Move this over here. Okay. Okay, so we have the warm-up, we have builds, we have bookends, we have kick sets, we have pull sets, core kicks, treading water with butterfly kick. Again, this one's probably one of those in the drill section, I would say. T2D. And we're just going to paste it down here. Okay. And we also have to consider intervals for training between the cooldown. Okay, so if we were to create a swim workout, it would be some subset of this. And I would argue, depending on what the swimmer needs to train, I would, select from this set like a different group of things. So probably if I were to create this for myself and I was just going to do a swim workout, I would say, first of all, I'd swim. Because I'm specifically training butterfly, I would not swim so much of the other strokes, besides maybe a bit of breaststroke. So what I would probably do, one set that I would like to do is I'd probably do a bookend set where we do, let's see. So the set would be 4 i's equal to 1 to bookend iterations, whatever this is. And in here, I would probably say we want to swim. I'm going to reckon, actually, I want to do 50, 150 is what I want to do. That would be my personal thing that I would want to do. So I'd say 50, swim. Let's do breaststroke. 50. And this is going to be easy. Followed by butterfly hard. So I would say, because again, the short axis strokes, I feel that they work together. So I would say 50 breast, 100 fly, and then 50 breaststroke, right? So if we're thinking about how the AI would think about this, probably we want to just give them a heuristic or something that says, short axis strokes should be kind of lumped together and long axis strokes should be kind of lumped together as well. For builds, I would probably do a 200 build. So I'd say build those. We'll probably say 4 i's equal to 1 to build iterations. And in here, and I would prefer to do 200 builds. I would say swim, fly, 200, build. So that means every 50 you get kind of a bit faster. So actually let's mark that out so people understand. So here we do 50, and this is going to be easy. And then we do strong, hard, and then race pace. All right, now the intervals for this would be kind of difficult, and also depending on this also depends on what you're training for. If you're training for 100 butterfly, you probably wouldn't do a 200 butterfly, right? You would probably specifically focus on that 100 butterfly, and you do a bunch of build iterations that are just 25, 25, 25, 25, or something like that. For the kick set, here, I don't know what people think about this, but I would typically say for I is going to be equal to 1 to kick iteration or something like that. We'll do K iteration. I'm not doing a good job of naming this, but end here. I would probably say for the kick set, in fact, we could probably put the kick set with something else, but I do like to have like my own long kick set. I would probably just use swim, 200. So fly, 200, probably hard as well. You probably don't want to, these you don't need to do race pace or anything like that, but just the thing is, this is actually, so the kick set is different than these sets up here. These are to help you overall swimming. The kick set is specifically to build muscle in your legs that you need for kicking. So that's a bit different. And same with the pull set in here. This is again something that you probably do a longer set because you're trying to do muscle growth in these guys. So here we're going to do 4 I is equal to 1 to pull iterations. And again, instead of like doing this thing where you get into like race pace or whatever, you probably want these to be just strong instead of hard. Sorry, I'm really not good at naming these things. Like, this is based on what my coach would always say, like strong, hard, this type of thing. Here, and so this is going to be fly 200. Again, just pull iterations. I guess in principle, it should be... I need to find a better way of like notating this, but I think we'll figure that out in a second. Okay. Again, breaststroke probably is going to be done as the, how do I put this? The complementary stroke to butterfly. In core kicks, underwater, stuff like this, these are all things that you only select one of the following, right? You don't typically do these regularly, right? But so what I'm going to do is I'm going to kind of like notate what I would probably put in for each of these guys. Although I don't know how useful that is. So for underwaters, again, now here's the thing. Underwaters are not super useful, I believe, unless you have an interval on them. Because, I don't know why, like, here I'm just talking about this at random. Because, you know, you can get to anyone can swim from one end to the other end. It's not super hard. What's hard is going from one end to the other end in a particular time and then doing it again and again and again, right? Doing that when you're out of breath is the hard part. So you specifically need a strong interval on this. Okay, so now this is the question. How do we specify intervals? I suppose we can just specify intervals by saying the following. We can say strong, and then we specify pull, and then we specify interval in here. Something like this should work. And then here we do kick interval, right? So every time we have an interval related to it, and so this whole thing has an interval related to it. How do we notate like an interval for a group of objects? I mean, I suppose we could create this like a separate function that is the build iteration. I don't know. We have to think about that. Also, like, how are we going to provide this for people to say, like, this is what you need to do? It gets kind of complicated. Okay. But ultimately, I think this is a pretty good, like, I think we're getting somewhere. Like, we just need to think about how we're going to do this. So, yeah. Okay. I know we're halfway through the workout, but I'm trying to think of like how the AI would do this, and how it kind of thinks about what needs to happen next, and what information we can provide to the user. So I think what I need to do is kind of maybe read some of the links that Martin has given us, and go from there. So I think I might do that on my own time, maybe tomorrow, and then we can figure that out. For today. Again, I've been kind of notating how we go about this. I think what we want the AI to do is we want it to provide these modules that have a different difficulty. And then after giving it like a set of different difficulties, we can then have the AI scale in difficulty for different... So should we have it scale in difficulty for some predefined workouts? Like, that's super easy. Then the n-dimensional space is like 1. It's just difficulty scale. So we want it to be able to go through a difficulty scale, and we also want it to be able to go through like kind of putting different sets in there. But honestly, like, I don't know if I trust an AI. Like, I trust myself to know what I need to put in my own set, but I don't know if I trust an AI to tell me what I need to do. In which case, why do I need an AI for this? That's a good question. I could just create my own sets. But I really want to be able to say I have an AI swim coach. I think that's really cool. Let me go here. There. Okay, let's go here, open that, paste this, there. Oh, I'm downloading a book now. Okay. CD projects, swim. Swim, notes, move, downloads, by sure, that'll do. Okay. Why are there so many dots in that? Huh. I see. Good. Oh, no, this is great. Okay. A complete book about swimming techniques, especially part 2, would be useful. He broke through. Okay. Let's go ahead and just delete some of these pages that we don't need anymore. And actually, you know what? I think at this stage, we kind of have an idea of what the coach can do, right? So the coach can... Okay, we know what the coach needs to do. The coach needs to be able to specify the sets that we're doing, right? So it kind of like picks these guys at random. But then we have to provide feedback. And I suppose the feedback that we need to provide is whether we felt that that set and that exercise was actually useful for our development or not. That's what we need. Now, that's different than whether we liked the set or not. In fact, probably the direct opposite of that. So probably every day what we need to do is provide feedback and say, hey, was this a good workout or not? And then that's just how we have to do it. And so that's going to be how it learns. We allow it to just kind of like amble about, figure out what different sets to put in, what the difficulties of these sets are. And then we explain, hey, we want it to be more difficult. And so slowly we tailor it in to provide sets for us that are reasonable, right? In addition, we should also allow it to have a set of different exercises that we could do, in terms of like running and stuff like this. So like, how long we need to run and all this kind of stuff every day. And so the idea is basically we have a bunch of different sets and we have a bunch of different like scales for these sets. And then we have some sort of random, and then we have some sort of random, like movement. So that every day or something like that, it does a set that's different than the day before. That might be a bit difficult to do. But ultimately, okay, I think this is a good stopping place for today for the AI swim coach, because we have an idea of where to go. We know how to do it. Now it's just a matter of creating that n-dimensional space, which is essentially all the different workouts, like all the different builds, all the different sets that we could do, both on land and in the water. And then it's just a matter of creating the AI that can go through that space and giving it feedback every day to let it know whether it did a good job or a bad job of creating that workout. And then every month or so, we have to give it timings. Now, the problem is that really and truly, we should be going off of timings for the AI swim coach. Like, that's what we should be doing. Because, having a human go in and say, oh, this is a good workout or this is a bad workout, that is probably not a great idea. So probably we want to... probably want to go with times over anything else. Random question. I just learned about you. What is klima? Where did you read klima? Probably down here somewhere. Klima. Where is klima? Oh, it's not. Wait, where did you read about it? Oh, GitHub. Interesting. Yeah, so klima is the climate machine. So, 1 second. climatemachine.caltech.edu, I believe. Okay. Climate machine Caltech. I thought that's what it was, but maybe I had it wrong. Klima.caltech.edu. Okay, sorry. So it was the old project that I used to work on when I worked at MIT. Well, rather, it is still going on. I just quit MIT and I'm no longer working at the project. But this is what I have been working on for the past year, related to just simulating the climate and stuff like that. So that's what I had been working on last year. Okay, so I think this is a good place to call it for today. Let's see who's live and who we want to raid at the end of stream. Master Mindo is live. Strager is live. Let's see, Tayunui is live. Enceladiosaurus is live, and they're doing machine learning, which might be useful. Let's do Enceladiosaurus, actually, because they're doing machine learning, and that's related to what we were talking about as well. So, raid, Enceladiosaurus, Russ, hello, Let me try that. Did I get it right this time? I think so. All right. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. Again, tomorrow is the last day I'll be working with Klima. I should be streaming at about the same time, maybe 4 to 8 p.m., something like this. We'll just go for a few hours. But then on Wednesday, I'm hoping to like kind of have Twitch be just my normal working hours and see what we can do about that. So we'll see where that goes. Anyway, guys, thanks for coming in. Again, have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. We'll do more convolution stuff. And then we should hop into something interesting in the evening again. I'm not sure what we'll do, but we'll figure it out. Thanks again. See you next time. Bye, guys.